Just a moment.
Okay.
Okay. Okay, great.
Are we on?
Yeah. You're fine.
I
We
can.
are raising, yeah, the numbers are
We
becoming
can
higher and
wait
higher.
maybe a minute or two. The
Yeah.
attendees are coming.
Yeah.
Yeah.
Yeah. Almost 100 now.
Very good.
Yeah.
You let me know when I can start.
Okay. Okay. 109. Yeah.
I would say it's okay.
Yeah.
Okay. Good morning, everyone. Welcome to the webinar. On behalf of Croatian Academy of Technical Sciences, of which I'm the member, and the Croatian Hydrogen Association, of which I'm the founder and the president, I organized this webinar on hydrogen in energy transition. I also must mention the Faculty of Electrical Engineering, Mechanical Engineering, and Naval Architecture at University of Split, and University of Mechanical Engineering and Naval Architecture at University of Zagreb, who are the co-organizers. And of course, I must not only mention, but thank the Center for Sustainable Energy, Water and Environment Systems, who did everything to organize and run this conference hopefully smoothly. Hydrogen has come to a center of interest lately, even in Croatia. We have over 200 registered for this conference, which shows a great interest on hydrogen. When I started working on hydrogen, that was about 30-something years ago. It was a pure science fiction. But today, 30 years later, we are seriously talking on the highest level about deployment of hydrogen technologies and a widespread deployment. And now in Croatia, everybody is talking about hydrogen. I mean, as the president of Hydrogen Association, I receive phone calls almost on a daily basis, people asking, what can I do? How can I get involved? So that's really very excited. We have prepared a very interesting program, I hope so. And I would especially like to thank our foreign speakers who immediately accepted to talk at this conference. I didn't have to twist their arms. So without further ado, I would like to start with the program. And the first in our program is Mr. Yorgo Hadjimarkakis. He's Secretary General of Hydrogen Europe, and I'm sure he will tell you all about hydrogen in Europe. Yorgo, it's your turn.
Hvala lepa and Frano, and thanks very much for the invitation to this, for us, important webinar. I hope you can see already my screen. My name is, as you mentioned, Yorgos Chatzimarkakis, Secretary General of Hydrogen Europe. And you can see here, just a second, need to get into, yep. You can see here, so to say, the membership of Hydrogen Europe. There are also, from Croatian side, rather scientific members, but this is growing. Friday this week, so tomorrow we will have 250 members. This is quite remarkable. I started 5 years ago, and it was even 5 years ago more science fiction than reality. But this has changed, of course. Today, hydrogen has become systemic, and hydrogen has become also real. At least in the political discussion, at least also in the planning and project engineering. And I will try to explain where we are at the moment and which are exactly the challenges for this year, 2021, because it will be one of the most decisive years for hydrogen in the near future. Now, first of all, I would like to just congratulate, and this will be taken up by Bart Biberg later on, that we also witness this new partnership that we have, Hydrogen Europe, and well, the Hydrogen Europe research. We will enjoy another 7 years of research innovation. I think Bart will elaborate on that. That's his specialty, and he's the executive director of the partnership, the old partnership and the new partnership. Now, what did we do? Just to describe how we got there. Indeed, exactly 1 year ago, we came up with the vision paper that you see here on the left-hand side, which is called a 2 times gigawatt initiative. It was quite visionary a year ago. Today, it's the plan of the European Commission. And what we wanted to do is to show that basically ramping up the main technology that you need in order to produce hydrogen in a decarbonized way, namely electrolysis, will be the basis of having a disruptive change towards a net zero emission society and economy. And this paper, to be honest, was doubted. So even a year ago, there were even in the membership and even in the electrolyzer manufacturing membership, people who said, wow, that's too visionary. But then the pandemic broke out. Exactly 1 year ago, we organized our last physical meeting. And from then on, things had to be online, like this meeting here. People got used to it. At that time, it was maybe new. However, a few weeks later, the executive vice president of the European Union, Mr. Franz Timmermans, responsible for the climate agenda of the European Union, called and said, hey guys, what about your 2 times 40 gigawatt plan? Is it a good plan for the European Green Deal? Is it a good plan for a change? Because we see that economy goes down and we need to use this disruptive situation like a first, second world war, like any major crisis, in order to get things into a new order. And we said yes. And we also tried then to build up upon this 40 gigawatt a matchmaking program between supply of hydrogen. So what does it mean? What can you do with this volume? 2 times 40 in Europe and another 40 in the neighboring countries like Ukraine, Morocco, but also MENA region, Saudi Arabia. What can you do with that? And fortunately, with the help of Bart Biberg and his joint undertaking, we had a study of demand, of hydrogen demand. And so we could match it. We could bring together the cost, so to say, the demand and the supply, and could calculate the costs. We came up with a 430 billion euro demand for the whole project. I will describe it later on so you see where we are. The most important point is that our membership and the CEOs of these companies committed to it. They signed up to it. They said, we support this plan. And that made up, so to say, the roadmap towards a European clean hydrogen strategy. We, of course, also accompanied that with some recommendations for the regulatory aspects, because to build up something needs also regulatory aspects. The main tool for that, and you see I'm standing in front of the banner of the logo of this association or this alliance, is the so-called European Clean Hydrogen Alliance, with the aim to kickstart this EU hydrogen industry to achieve the climate goals. It was established 8th of July last year, or launched, the very same day when the European Hydrogen Strategy was launched. And it shall implement the hydrogen strategy. Now, what is the goal? The goal is to have, today we would see approximately 500 companies, but now we have much more than 1,000 members in that alliance already. So the 1,000 companies that are interested, we see them already now. But you will see some consolidation up to until 2050. So it will be a part of the shift towards zero emission, a part of implementation of the European Green Deal. The clear target that was set in the European hydrogen strategy was to build up 6 gigawatt of electrolyzer capacity until 2024. That's quite ambitious because that's now. So we need to start immediately. And every conference that we do together with the European Commission, we can see the pressure they put on us because they are under pressure. They set themselves this goal that is derived, of course, from the 2x40 goal. And you see it there. It's now part of the European strategy, 40 gigawatt in Europe until 2030. What is the main goal is, of course, the achievement is to abate in the energy system, but not only energy, also industry and mobility. That is why I cannot disconnect it. I'll come back to that. To abate CO2 emissions. So 9 million tons per year as of 24 already, and 90 million tons per year as of 2030, and of course, growing number. And it goes without saying that this investment needs money, and we are not at the 430 billion because the 430 billion include, of course, all the investments into renewable energy or other decarbonizing energies like pyrolysis. So the 430 is not just hydrogen technology. However, only hydrogen is foreseen by the Commission as of 5 to 9 billion until 2024. Here I have to say, already the member states have earmarked money in their national hydrogen strategies. And we can see that this figure that you see on the right-hand side, 26 to 44 billion, has already been reached. So 46 billion have already been earmarked by member states until 2030. And it's not all member states, it's just 8 member states. Now, what we will do and what we need in order to ramp up these projects is a financial engineering. What you see here is different possibilities, funds, but also tools to do it, because different aspects will need different partners. Bart will speak later on about the FCHU and the future of this partnership. I will be tomorrow morning, for instance, in a workshop with the member states, Croatia included, on IPCEI. You see that is the mauve arm here. The IPCEI is the important project of common European interest. I'll also refer back to it. Now, let me just jump into our blueprint, the 430 billion blueprint. And you will see here already how this translates into the different fields. And it's interesting to see also the distinction between private sector and public sector. And you will see that, of course, the public sector plays a very important role. So you need the commitment. That is why in the European Clean Hydrogen Alliance, commissioners, but also ministers are part of it. You need public money. At the same time, it leverages, of course, private investment. And what you see is that on the production side, there is a lot, of course, and most of the production investments are associated with additional 159, 160 gigawatt of renewables. In order to make 40 gigawatt electrolyzer a reality, you need a lot of more additional renewable energy. That's why in the European Clean Hydrogen Alliance, we are working closely together with our friends from the renewable energy. The electrolysis represents 7 megatons in this plan, and low carbon hydrogen. So other technologies, I mentioned pyrolysis, I could mention ATR, the autothermal reaction, also 9.6 megatons. So it's also not to be disregarded. Infrastructure, here you see also investments, also by the private sector, whereby we calculated the regulated bodies like TSOs to the private sector. And of course, the end use means in industry, in mobility, but also in the energy system, you have also the share here. All in all, you see how the investments break down. On the right-hand side, I'm not going to it, you can see the CO2 reduction from the proposed hydrogen end use in million tons. And you can see that in steel, this ratio is quite high. Although in steel production, where you go from coal-based production of steel to the DRI, so the direct reduction of iron ore, but here you have a quite high abatement rate, which makes sense in order to invest into the steel. Let me come to the next slide. Here you see, and I will be happy to share these slides with all of you, so you can later on also see how this breaks down. But in the infrastructure, where we need investments, of course, to store hydrogen, but also to transport hydrogen via backbones, so pipelines, and via port facilities. And the storage will happen in depleted oil and gas fields, but especially in salt caverns. Here you see how these investments break down. And we also see that it's quite a considerable part of private investment involved. The fueling infrastructure will play also a role, but compared to especially the storage aspects, which is important for the energy system, because that's the main role that hydrogen can play to balance the difficulties that exist because of more renewables. Renewables are intermittent, so they create frictions to the grid. Sometimes you have too much, sometimes you have not enough, and that can be balanced by seasonal storage or by long-term storage using hydrogen. And that is the major achievement, I would say, of hydrogen as an enabler of others. If we look at the end-use related investments, so in which fields we will use hydrogen, so grid balancing, you can see that down there is not the biggest one. It plays a role. I know that this is a field of special interest. And you also see that, again, here in steel, you have clear investment, and you have CO2 reduction that are in the steel case quite high. You see that on the right-hand side. So green steel provides the most efficient decarbonization opportunity, which is why we are very happy to see announcements of steel companies not only to join the Hydrogen Alliance, but also to start immediately. Liberty Steel, it's a still London-based company that produces to 60% steel in Europe, has now announced to become net zero until 2030 already. That's very challenging, but that also means that we need to react immediately. But also aviation is a very important part, and road and maritime transport. Not going into detail now, but especially in aviation, we had already a first flight with e-kerosene from Amsterdam to Paris using synthetic kerosene that has been produced on the basis of renewable hydrogen and biogenic or circular CO2 in a flight from KLM, Air France, from Amsterdam to Paris. We also have clear plans for the decarbonization of the road, the use of roads. Here you see the 10E and the 10T network. 10T is the Trans-European Networks for Transport. This here is the 10T route from Sicily to Sweden and Norway. Why did we choose this as an example? Because the companies that will produce fuel cell trucks that can use hydrogen immediately in fuel cells come from these countries. So it's the companies that have announced this are Volvo and Daimler that created a joint venture called Cellcentric. And they have already started to produce fuel cells for trucks, and at the same time Iveco from Italy. So Sweden, Germany, and Italy are, so to say, the countries that host the OEMs that will produce these trucks. And this 10T core network corridor, ScanMed, Scandinavian Mediterranean, has some elements that you can see here on that slide. So the fuel consumption would be 7 kilo per 100 kilometers. You have an annual mileage of 120,000 kilometers, and we want to have 78,000 trucks in the next years on that road. Here you can see how this would translate into 23 and 2030. And the capex that you see here will be needed to be invested and co-invested by the public. And that's where we are working upon at the moment, that we want to get in the projects in the Alliance, but also in the IPCI tool, lots of these trucks supported. We had excellent talks also to Renault, and we are looking also forward to Renault's contribution to that. It's a step-by-step approach. So what we expect until 2030 is 39, so 40,000 heavy-duty vehicles, 218 hydrogen refueling stations with 6 tons of hydrogen per day capacity. We see a demand of 328,000 tons of renewable hydrogen per year, 4.6 megatons of CO2 emissions per year. Well, and the cost for only the hydrogen refueling stations are already 1 billion. So you see that we have quite substantially done our maths and are now building up these projects within this alliance and within the IPCI. I would, Frano, I would say and stop here in order to get some of questions, because I know that some of your members are interested in questions, and that's why I would be ready to answer them, chat or directly as you wish.
Okay, thank you, Jorgo, very much. I don't see any questions, but just a comment to the audience that if you want to ask a question, type it in the chat, and then we will read it here, and the speakers will answer. In the meantime, while we are waiting, if there are any questions, I can ask a question. I noticed that in one of your slides, there was a transportation, and then there was a heating, hydrogen's role in heating. Can you explain a little bit what is there included in the hydrogen use in heating?
Yes. We have at one of our roundtables at the European Clean Hydrogen Alliance was called heating in the past, but they wanted to rename themselves to buildings. So what is meant is to use hydrogen especially basically for fuel cells in buildings, for the creation of heat, but also electricity. Let me give you an example, a very simple example, which is basically a first business case. You might have heard that the big data centers, and they are consuming a lot of electricity at the moment, especially because of these video conferences, but they are in a danger to be expelled from cities. So Amsterdam has expelled, I think, the Amazon data center because it was consuming too much of energy. What is done then is you can locate the data center very close to a pipeline. At the moment, it's natural gas pipelines. And with fuel cells, you can produce both electricity and heat. And this is the plan. There are some companies, I would mention in this case, especially Bosch, that are producing exactly the stationary fuel cells that on a modular basis can produce as much of electricity as the data center needs. At the same time, you have heat as a production. And this will then help buildings. So, and we are very much advocating as Hydrogen Europe this system approach where the heat also of the data center will be used for buildings. So that's the
okay.
idea. Yeah. Thank you.
Thank you. There is a question. It says, is blue hydrogen still a goal in the meantime while green hydrogen capacities are being achieved?
Yeah, that's a very good question, because basically people think the big discussion is between blue and green. We never liked this color approach, because in the end, hydrogen has no color. Of course, the origin of hydrogen is important, and most important point is the carbon content. That is why we, as Hydrogen Europe, try to define, together with the Commission, a threshold of carbon content. This week, the Commissioner for Energy, Mrs. Kadri Simpson, has mentioned a threshold. It's not carved in stone yet, but she mentioned a decarbonization rate of 80%. So that means that most of the so-called blue hydrogen technologies, like SMR, steam methane reforming plus CCS, carbon capture storage, they lead to 60%. So you can see already that they wouldn't qualify for the long run. They might qualify for the short run, and that is why it's of utmost importance to have a clear threshold, could even be 90. I don't exclude that, because the 80 or 90, it's a question of political discussion and decision. But then it's up to the regulators to talk about lock-in effects. Any technology that does not reach the threshold of 80 might help now. Take the port of Rotterdam, which is emitting nearly 1/3 of all the emissions of the whole Netherlands because of refineries mainly. If you use blue hydrogen there, or the technologies that you have, you can reduce at least by 60% now, because the technology is ready. But they won't get certificates for this hydrogen after 25, after 30. It's a political discussion, needs to be discussed. And that's how you stop lock-in effects. So, and everybody would then invest into only high decarbonizing technologies like electrolysis, like ATR, like pyrolysis, to mention a few.
Okay, also one very appropriate question. Have you been thinking about some joint venture with the European Battery Storage Association or similar in order to increase and develop mutual applications?
Well, there is the Battery Alliance, which is, so to say, the sister of the Hydrogen Alliance. And of course, we are to a certain extent also cooperating. However, I would have said the Battery Alliance is the big brother of Hydrogen Alliance. It's not true. They have less than half of our members. So the interest into hydrogen is much bigger. Why is it so? Because it's more than downstream. Batteries is rather downstream, whereas hydrogen is upstream, midstream, and downstream. So it encompasses the whole value chain. And that is what makes it more complex, but also broader. And battery, I don't want to preempt any discussion, but battery in the long future will be an integral part of a hydrogen-based economy. So what do I want to say? It's not either or. This is stupid. This is Elon Musk. This is Elon Musk stupidity to say fuel cell are fuel cell. This is marketing, and he did well. He became the richest man on earth, not for a long time, you will see that, but it was marketing. For us, it's not bullying somebody out. For us, it's the combination of all technologies, and hydrogen can enable batteries to become more efficient. I mean, I'm driving a hydrogen car, and of course I have a 40 kilowatt hours battery, a buffer battery, that helps me very much to manage better the energy flow. But it's not heavy, and it's not a plug-in. It's recuperating from driving. So it's a perfect combination. This is what we thrive for. We thrive for a perfect system efficiency, also material efficiency, by the way. Everybody knows that hydrogen is cyclical, and also that fuel cells have a very, very few part of rare earths, mainly platinum, and it's only 2%. The rest is stainless steel. In batteries, you have a different field. You have a different approach. You have a lot of rare earths and scarce elements. And this is how we can use them batteries only for cases where it makes sense, so small distances, and not use it for cases where it doesn't make sense. So material efficiency, element efficiency will also become a very important part of the European Green Deal. Thank you.
Okay, thank you. I think we have to keep the schedule. So I got the internet connection is unstable. Can you hear me? Yeah. Okay, thank you, Olga, very much for your presentation. There are some questions, but I will leave those questions. We can ask other speakers as well. You don't have to answer every one of them. I know you have a very busy schedule, so thank you for coming to this webinar.
Many thanks.
Okay, the next speaker will be Mr. Bart Bijboek. He's a director of the Fuel Cell Hydrogen Joint Undertaking, or it will be called Clean Hydrogen Partnership or whatever. Bart will tell us about the new organization. Bart, it's your turn.
Thank you very much, Frano, and thank you also for the introduction. And indeed, it's a good opportunity now to explain a little bit what we have been doing in the FCHJU and what we will do in the next partnership, which was announced just last week. I also prepared a presentation, and if everything going right, you should see my presentation now. Is that okay? You see it? Do you see my presentation?
Yes, we see.
Okay, great. Right, so just to explain a little bit who we are. So we are a public-private partnership. We have supported so far now 285 projects. We supported that for just a little bit over 1 billion euro. Since this is a public-private partnership, we also expect a similar amount from the private members. So since 2008, when FCHJU was launched, we have now spent publicly and privately together about 2 billion euro. You see our members. I mean, we have Hydrogen Europe. We heard just Jorgo, but they have now already 250 members. I continuously need to update my slides. And then also Hydrogen Europe Research is another association, 83 members. In the middle, we have the European Commission, which is a very important member because they give us, of course, the money that we can use to support all those projects. We're working on energy, transporting, but also very important on cross-cutting activities, which is about standardization, safety, and education. One of the activities we did, which was quite successful, was the hydrogen valleys and working with regions. We believe strongly that working with regions is very important to boost the whole hydrogen awareness in Europe. I believe that also the regions were very instrumental to put hydrogen so high at the agenda at many in Europe, but also at many national governments. Because regions are, first of all, close to citizens. Citizens are asking for solutions to their local elected people, and these local people need really to come up with solutions. So that's why we are working with almost with 100 regions and cities in Europe. Also in Croatia, of course, we have cities or regions working with us as Split and the county of Split and Dalmatia. Some of those regions, they said, well, we would like to go faster. And so they assembled themselves in the European Hydrogen Valleys Partnership. I think at the meantime, there are already 40 regions now joining. These are regions really that say, look, there's a lot of potential for job creation in our region, a lot of potential for growth. And that's why they wanted to go faster, and they assembled themselves in this partnership. On the other hand, we had regions that are not yet so advanced in this technology. That's why we launched the Program Development Assistance Program. And you can see here we have also Zagreb being part of this Project Development Assistance Program. It was launched last year. We have quite a lot of interest there. And I can tell you that this will be repeated. So after summer, we will launch again a Project Development Assistance Program, really to help the regions to bring their ideas, which is not yet very mature, to bring this really to a matured level so that they can go with their project proposal to national, regional, or European level for funding. Basically, what we are doing in this Project Development Assist, we pay a consultant to help them. And in the middle, I mean, I was very happy last year that our president, Ursula von der Leyen, she said that the Next Generation EU, which is basically the recovery fund after when the pandemic will be over, they really want to invest a lot of money in the economy so that we are back to before pandemic level on growth. And so hydrogen, she believes hydrogen valleys in particular is really a big part of that. We have already a couple of projects in Europe on that. One is Big Hit, northern part of the UK, Scotland, where we produce hydrogen on the islands, bring it on the mainland. We use it for various applications, but it's still it was very small, but it was really a good start. We said really we want to make a big hydrogen valley in Europe. We got a competition. We put 20 million euro on the table. Northern Netherlands, they won the competition. And now they are building this hydrogen valley. You can see there's a lot of partners. We will use it in many different sectors, mobility, also for storage, production, and so on, and in the industry as well. What was for us key in such a hydrogen valley is this sectoral integration. We really want to show that all the different sectors, mobility, heating and cooling, industry, they're all connected through the usage of hydrogen, where you, for example, have a central point of production and then you distribute it to all these different users. And after that, we said, well, now we have a hydrogen valley, why don't we make a hydrogen island? And we did last year a competition, and I just signed last December a contract with a beautiful island of Mallorca, where they decided basically to use hydrogen to decarbonize parts of their island. Also here, same idea, sectoral integration. You can see they use it for the injection in the gas grid. They will use it for heat, but also to power buses, etc. Really, again, very beautiful, the sectoral integration. However, hydrogen valleys, we can also think about future hydrogen valleys. We think about making cross-border hydrogen valleys, so that, for example, regions that are located close to each other, and we can connect them together through such a hydrogen valley. We can think about ports locations, airports, industrial hubs, logistical hubs, and why not build the first hydrogen city in Europe? Maybe Zagreb, I don't know. We also work on hydrogen valleys on an international level under the flag of Mission Innovation. They have their challenge number 8, which is about hydrogen. You can see on this website, I have the link there, that we gathered around 32 valleys across the globe on this platform. What is the purpose is really to exchange learnings, to accelerate again the transition to clean energy by using hydrogen. I can tell you it's very successful. There's a lot of interest in this website. So if you would like to know what's going on beyond Europe, I definitely would recommend you to have a look to that. A second thing which was very important in the acceleration of hydrogen in Europe was the electrolysis projects that we did. We started 10 years ago in Belgium with a 150 kilowatt electrolyzer, at that time quite challenging for our industry. And what we did in our program was really pushing the boundaries, really pushing the envelope, really to double almost like each time. And now we are at 100 megawatt because last year the European Commission, together with us, we launched the Green Deal call, requesting for a 100 megawatt electrolyzer project. And I can tell you that we received 16 proposals, which is quite a lot, and also shows that basically the industry is ready and that there are also customers for all that hydrogen. Otherwise, for sure, they would not make proposals. So we are looking forward now to see who will be the winner, but I can tell you there are really very beautiful projects in those 16 proposals. The next is, of course, to go to gigawatt scale, as you heard. I mean, the European Commission has a clear target, 6 gigawatt by 2024, 40 gigawatt by 2030. So we really need to push it further, the envelope, to go to gigawatt scale. But I believe that we can be quite, sorry for that we can be quite happy to see that within 10 years, basically, we move it from about 100 kilowatt to 100 megawatt. Of course, it was already a part of the discussion or in the Q&A with Jorgo. It was about the color of hydrogen. We have developed with the project Certify a guarantees of origin scheme. We have in the meantime already more than 70,000 GEOs. We have done a lot of piloting projects. We have one in France, Germany, Belgium, and the Netherlands. Different pathways to produce hydrogen, and we audit them and we give them this GEO according to their production pathway. We just signed now a new project, which is the third phase, Certified 3, which really has to set up a platform for these pilots for the JU, but across Europe, so in the 27 member states. And I also hope that we will see something happening in actually in Croatia. We don't do that alone. We also, in this third phase, we work with the IAB, which is the Association of the Issuing Bodies. These are all the bodies in Europe who basically assemble themselves in this association. Also, we work together with some regulators in Europe, so electricity regulators in Belgium and Austria, in order to really do this rollout in Certified 3. At the same time, on a global level, we work with the IPHE on the production analysis methodology. I mean, hydrogen can be produced in many different ways, but what is very important that globally we agree on a methodology to calculate the CO2 footprint still. And later on, the amount of CO2 that would be then be the definition for green or blue or even other colors. I mean, we have yellow, we have different colors, even turquoise recently I heard from pyrolysis. So really that doesn't matter at that time. This is a political discussion. What we need to agree globally among authorities is what is the methodology, and it has to be the same, because this is so crucial to really unlock also cross-border trading. We also work a lot let's say in transportation, up from cars, forklifts, up to aviation. We have one project which called hydrogen mobility, where basically we are putting coordinated among various member states and stakeholders. We coordinate where do we put the hydrogen refueling stations, where do we put a fleet of cars, in order really again here to accelerate, to show that it's possible. And you can see that in H2ME, for example, we have almost like 1,400 vehicles that we are supporting. We are building more than 50 of hydrogen refueling stations across those member states. If you want to know where all the hydrogen refueling stations today are in Europe and whether they are open in maintenance, I mean, we have launched a project in the Commission to visualize real-time data for each hydrogen refueling station. You go to the website h2map.eu. There you can see, for example, if you want to know about the 700 bar or 350 bar for buses, where they are, if they are open. So this is a tool. Please use it. We have today around 140 stations in Europe, and of course, every week we're increasing that number. We also work on buses. We have so far put orders of 230 buses of the 295 buses in JIVE and JIVE 2. This is the project names. We have already 5 suppliers. The first buses are really being delivered in Cologne, Wuppertal, and Po. We will have also other sites, as you can see, where we will put buses. What is very nice is that by the end of the year and by end of 2021, all those nearly 300 buses need to be put in place so that we can start monitoring the results. And also, because of this big scale project, this triggered also a lot of other OEMs' interest to start working on hydrogen buses. So I believe from the 5 suppliers we have today, probably we will go up to 10, which is good for competition, which is good to bring down the cost. We also work on trucks. We have 2 projects, H2Hole and Revive. H2Hole will be used in the daily operations at Carrefour, BMW, production plant, by Air Liquide, and so on. We will see this next year, the first deployment of those trucks. On the other hand, we also have the refuse trucks. It's a bit of a different operation. It's back-to-back every day. And we have already in Breda the first truck deployed. As a summary, we will deploy 30 trucks in 13 demonstration sites in 7 countries. What was very important that And last year, during the European Hydrogen Week, the industry committed to put 100,000 trucks and 1,500 hydrogen refueling stations by 2030 in the European Union. We also work on trains. I mean, we all know the trains in Germany. We did a study after that. It's like, okay, what is really the business cases? You can download the study. And also there were a few recommendations about further developments or R&I that was necessary for trains. We did that. We made a call last year, and now we will fund now the project FCH2 Rail in Spain together with the CAF. So they get 10 billion euro to put also in Spain a hydrogen train. Maritime. Also here, a bit similar story that we have with the electrolyzers. We started really with 50 kilowatt scale, and we pushed it now to the multi-megawatt. We have now just awarded in 2020 2 ships. It will be propelled by liquid hydrogen. 2 ships in Norway, roll-on, roll-off ships. So we're really getting here in the megawatt scale, and this is, I believe, very important to demonstrate. Here again, I want to mention clearly that there is no one size fits all. We will have different fuels. I mean, it was already mentioned by Jorgo, for example, ammonia, but also we can have LOHC and also pure hydrogen, depending on its application, the region where it will be applied, and so on. Also from fuel cell technology, we will see PEM, SOFC, and so on. Still a lot of challenges here. We have to scale up the fuel cells to really to more than 2 megawatt, but really to go to 10, 20 megawatt scale. We need to think about liquid hydrogen storage, so a lot of still work to be done here. We work also on ports. We have the project H2 Ports in Valencia, where we try to put reach stackers and yard tractors on fuel cells and propelled by hydrogen. It's a very small project, but it's an important project to start. And actually, the next step is now we are working under the CEM, the Clean Energy Ministerial, to build a worldwide hydrogen ports coalition. Probably by the end of May or beginning of June, it will be an announcement of a number of ports that will work together on hydrogen. We will also launch a European hydrogen ports coalition. We'll start a tender process by the end of this month, which then will result basically in a consultant that will build a European consortia of ports to really make a roadmap for hydrogen for those ports. We're working in aviation, the project Icarus, where basically we managed there to really demonstrate a fuel cell and a hydrogen tank to be built inside the plane, really in a different air pressure environment. And what was also important is that the whole technology or the fuel cell and basically also the tank was developed according to aviation standards, and that was new. We're working further. We will try to replace the ram air turbine. It's kind of safety device that gives electricity to be able to land. So we will replace that by a fuel cell. Also, we are looking for small planes to be propelled by hydrogen, as you can see here as well. This is the project Heaven. But we said, okay, this is all very small. We need to see it bigger. That's why we work with our colleagues in Clean Sky, which is another joint undertaking, actually on a study where we basically concluded that hydrogen propulsion for the big aviation is possible. We will build a first prototype by 2028. We believe that the cost could be limited, the cost up to $20 per passenger per seat. So clearly it is possible, and now it will be to the industry, the research and the public sector to work together to make it a reality. Also, you saw that France announced that by 2035 they want to have it commercial, which is possible but challenging. Also, we can use fuel cell systems for heating and also for electricity in homes. We have 0.1 to 1.5 kilowatt size of fuel cells. This is the project PACE, which putting thousands of those units in people's house. I can tell you now we have already more than 10 or I think even 20,000 of these devices installed across Europe. Prices going down thanks to our research that we have done. We also look in more commercial type of fuel cells, 50 to 200 kilowatt size. We have one project here in Torino. It's in a wastewater treatment plant. And basically the 175 kilowatt SOFC can produce all the hydrogen and all the electricity, well, all the heat that the plant needs and big part of the electricity. And then also we can look into multi-megawatt. These are projects basically outside of Europe. This is one in China, but also we had one on the islands, so in Martinique. So we see that the potential for multi-megawatt is rather outside of Europe. We also work a lot on educational activities. We train young postgraduates, young professionals, technicians, regulators, first responders, plenty of projects. So if you would like to get the material, do not hesitate, because we just have launched also at the end of last year the observatory. And actually in this observatory there is a section on education and training where you can find all the material. At the same time, this observatory is doing much more. It also covers all the technology and the markets. If you want to know, for example, how many cars we have in Europe or how many electrolyzers we have, you can all find that there. Policies, regulation, codes and standard, patents, publications, funding opportunities, everything is in this observatory. I think globally, I think this is the best observatory that exists, which is publicly available. So use it if you want to know more. Finally, very important, money. Where can you get money for your projects? Well, it was already mentioned. We will start by the end of the year a new partnership, which will be called the Clean Hydrogen Partnership. We will work on hydrogen production, on hydrogen distribution, and end use, but mainly the end use will be in heavy duty and industry. So we expect to start by the end of this year, November, I hope. We probably will have a first call in December this year. And as it was already announced, the budget has increased a lot. We had in FCH 665 million euro, and now from the next partnership, we will become a 1 billion euro partnership. We will do the first call, as I said, in December, probably 150 million euro, immediately followed with a second call, probably the first part of next year. Hydrogen will not be only be treated by us, Clean Hydrogen EU, but also in other partnerships like Processes for Planet or chemical sector, 2.0 is more transport, waterborne, clean steel, clean sky and rail speaks for itself. So you'll see that all those partnerships will now will have also hydrogen funded projects. But if you want to know where you should go with your project, you can always give us a call. There are also other opportunities. We have the Connecting Europe facilities, mainly infrastructure to be funded. We have the Innovation Fund. This is really for the scaling up. The IPCEI was already mentioned by Jorgo, but also do not forget the Next Generation EU. Now every member state is making their plans how to recover from the pandemic and kickstart the economy again. And I can tell you that hydrogen is a part of it. And I believe also you as an association and in Croatia for hydrogen will be very good to get into discussions with your government to put really ambitious projects on hydrogen in this Next Generation EU. Final message, well, we had a first European Hydrogen Week last year, which was amazing. I mean, we had more than 10,000 people from 63 countries joining in. And so we will have a second one. It will, at the same time, also the launch of our next joint undertaking be held on the 29th of November to the 3rd of December. I would say be there, but it's a bit difficult to say be there. We don't know how the pandemic will go, but I would say for sure log in. Thank you very much for your attention, and I'm available for questions now.
Thank you, Bart. This was very informative. I don't see any questions right now. Okay, there is one. Are there any mature projects on solid hydrogen storage?
Well, we have a few of those projects. I'm not sure what you call it, mature. I don't think it's yet mature, to be very honest, but there is a lot of, we have a couple of research projects in that area. I do believe that there might be a potential in some, let's say, in some areas to have solid hydrogen storage. I do see potential there, but it will be probably niche a bit, I guess.
Okay, so another question that was left from previous is, do we have a developed methodology to calculate carbon footprint for each technology for hydrogen production?
Well, I think I answered that in a way.
Yeah.
So we have with Certify, we are doing that. I have to say that it's not yet for every hydrogen production method. We will in Certify 3 include more hydrogen production methodologies and create a standard for that. So we have, I think now, I guess 5 or 6 already different pathways that we made a methodology. I think we will go now to 10 or 15 of them. So.
Okay, thank you. As I don't see any questions, I will thank you one more time for your presentation, and we'll go further. Next speaker will be Professor Robert Steinberger-Wilkens, and I asked him to tell us more about hydrogen R&D because as a professor, I'm also concerned about what's going to happen if we spend all the money on the deployment. Are we going to have any money to do research, and what should we be researching in hydrogen in the next years? So Robert, the floor is yours.
I'll just share my screen.
Yes.
So I slightly expanded the topic at looking at the relationship between mass rollout and research in a way. So this is not a sort of challenge to Jorgo and Bart. It's just discussions we've had in the past already, further expanded. Just hang on. So just 2 slides on what we do in Birmingham. So I'm head of the Center for Fuel Cell and Hydrogen Research in Birmingham. We're about 50 academics. We're the largest group easily in the UK, concentrating on these topics, and one of the largest UK university groups in the world. And due to the size, we cover all the topics from hydrogen production, from renewables, so sustainable hydrogen production. That also goes into this direction of all kinds of colors that don't really help, apart from green, but also low and high temperature fuel cells. And the main application is vehicles. We also run this TICHI master's program. I might come back to in the end. Now, just in general, when you introduce new technologies, you start with blue sky research. Then there's some research interest, might move out of universities to research centers. Then industry starts collaborating, that moves to the industry laboratory. You have product development and then market rollout. That's clear. But if you look at the time scale, that will take a long time. From the first messages that American scientists have found something in the lab to actually seeing this as a product, it can take very long. And that's the only true statements I think I've ever heard from Elon Musk was when he warned that his new batteries would take longer than some people anticipated. So, and this has always been reflected in the way the joint undertaking has been working. So this is the previous one, approach slightly changed later. So based on long-term breakthrough research, going to technological development, as you could call it, then also laying a foundation of regulatory arrangements, then the demonstrations and the market support, which was outside of the scope of the joint undertaking. And if you map that out as a process, so you start with design ideas, you have a prototype, you verify that, you have some field testing, and then you roll it out. And the time scale of that, as I said, 10 to 20 years. But in reality, once you get to verification, 10 years have passed already. So you're talking about technology that essentially is 10 years old, and by the time it's rolled out, it's 20 years old. So in between, you have to start working on the next generation, because after 20 years, you don't start from scratch thinking about what is the next. You do that alongside in parallel. So you have a second strand going on, and effectively, once that has reached halftime, you start the next one. So you have various strands going on in parallel. While you're rolling out one technology, you're already developing the next and the next but one. And that's important. And that's where research comes in. And that's how research works together with technology rollout. So there's clearly a role for science and for industry. And you can also map this on the technology readiness level, but also the market readiness level, which often is forgotten. And I've just put a number of projects, items here. That was the FCH program in 2018, I believe. So you can see so funded, or at least topics in the call of the joint undertaking at the time. So very basic things like solar thermolysis, also the normative, pre-normative research, next generation projects, things that were going more into the realm of prototypes and field tests and demonstration. And then there was the large demonstrations. And sometimes you did think this is not really a demonstration. It should be called a prototype verification. And demonstration, I'll comment more further. And then, of course, there's all the manufacturability. I'll come back to that in a moment. Cost reduction, building the supply chain, just as important as being focused on the rollout. So just to illustrate things that have happened in the past, we've had a development of very good 300, 250, 300 kilowatt CHP units based on natural gas in the 1990s. This was a product built by UTC or ONSI, which had a rollout of anything between 300 and 500. I've found different numbers there. Every single demonstration project at the time was equipped with this unit. And they also had a map forward. So that was then when essentially they stopped building them around 2000 because they didn't see a market prospect. Then there was such a public demand because nothing else was available that they actually started building them again. Had a plan for cost reduction. And just to point out, the largest part of cost reduction here is something I'll come back to later. So materials, manufacturing, and what then happened was the projected cost reduction curve, which you'll see in all the studies, everything done also for the joint undertaking. So the cost reduction for residential heating units, which Roland Berger did a couple of years back, they all follow this pathway. What actually happened was the cost came down and then went up again. Because you find issues with lifetime, you have to reinvest into materials. You might find you want to add some equipment, you want to make it more efficient, want to make it safer. So the cost does not naturally always go down. And this could have been avoided. I'll come back to that in a bit. Another example, MTU building the molten carbonate fuel cells. There were quite a lot of them around. So middle of the millennium, 2005, 2006. And then they hit the wall because they could not build anything that had a lifetime beyond 5 years. And what was very peculiar about the MCFC developments was there was no scientific base. Essentially, all the companies involved in this, so that was Ansaldo, it was MTU, it was Fuel Cell Energy in the US. Essentially, they refused to work with universities. They did not want cooperation. They wanted to keep this in-house. And last example, the CUTE bus project, a huge investment by the EU. So a huge project, a lot of money. And that's why I question these big projects and always being bigger. We need also to think for what is the money being spent for and what is the midterm aim. So in this case, 33 buses employed all over Europe. It was the first project of its kind. I was involved right at the beginning. Very successful, but to date, so that's now 20 years, Daimler, who built all these buses, is not offering a commercial product. They just refuse to do so. They're now, I think, announcing it for 2023 or 25. So effectively, you could call this a failure of investment. I'll come back to where that is to now. So what you see is, that's a friend of mine, Phil Doran, who once came up with this idea. You see things taking up, gaining interest. You see investors coming in. You see a hype. So we saw that hype around 2000 for fuel cells, and we're seeing the hype now for hydrogen. And then comes the point where people realize it's not the economic option that will be successful in the midterm. So the interest dwindles, or it's not as ready as people thought. There comes a veil of tears and death, and then things stabilize again. So I see this, we've just analyzed this for hydrogen filling stations. Hydrogen filling stations are an infrastructure, they have to be put in place. I would contest that it's the public who has to do this, it's industry has to do this, because they will be earning money with this. So you build the infrastructure and then it just sits there because there's no hydrogen vehicles. They will only come when the infrastructure is there. We've seen the same with mobile phones. It's all known, we've published this. You need a concept of how you will fill this valley of death. And there are ways of how the public can support it. I don't think in the way of subsidies. And there's clearly a background to this. There's a disruptive product, there's disruptive infrastructure, there's new players. These three elements define disruptive technology. There's some interplay. I would even contest whether a hydrogen car is a disruptive technology. It clearly has a disruptive infrastructure, but it's the same OEMs and it's still a car. It has 4 wheels and a motor. So now let's look at how this works, how this is, how this builds up a market rollout. So I'm not referring to the animals lemmings here, I'm referring to the PC game, if anybody remembers. So you have the basic research going on, coming up with ideas, then industrial development follows. Then you get some interest of regulation and policies. Think of maritime regulation for having hydrogen as a fuel on shipping or on aircraft. Then comes some more, and then comes market rollout. So somebody comes up with a product you can actually bring to the market. And you'll always have the lower steps preceding the later steps. And if you don't do that, you'll fail. So if there's no blue sky research to support industry, it will fail. And if there's no regulation and policy framework to support the rollout, it will fail. So why is that? So what happens? So let's first look at the science. What happens when industry, rollout, and science get disconnected? Then you lack the support university creativity. You don't have these 100 PhD students messing around, coming up with lots of stupid stuff, but 5 of them coming up with really essential new developments. You also have a decrease in publications. I've had a hard time researching for one of the students why Volkswagen stopped their high temperature PFC development. There's no literature on that. There's no literature on why it failed or why it was stopped. I just have word of mouth because I know a couple of people I've talked to. What you also get, so there's no input into new research that could circumvent the problem. There's also a divergence of research topics. If I talk to industry and say, this is what we're doing in the lab, they just shrug their shoulders and say, well, that's not our problem. So what is their problem? They won't talk about that. So the only approach I have is my PhD students are getting jobs with them, and I might be talking to them at a conference sometime. So in a sense, there's no kickoff of the next and next but one developments. That's how MCFC failed, or is not doing very well, let's put it that way. There is no university larger scale development that is looking at the issues of MCFCs and how these can be overcome in all kinds of funny ways, which might not be suitable and viable, but there will be one that will be successful eventually. And there's also a lack of what I call serendipity. So an SME coming up with something and supplier base delivering input. So what happened when I was in Jülich at the research center, we were at the Hanover Fair, and people came up to us and said, oh, that's a peculiar component you have there. We can make that for you in a very easy way. And that essentially started the developments with Ehrinklinger and Bosal to make cheap, thin, interconnects for fuel cells. But it came from a completely unprecedented angle. And if you're not visible and if it's not clear what you're doing, you just don't offer this angle. So industry, whether it acknowledges that or not, just needs this support from free research, from people who are just generating ideas, no matter whether they're practical or not. At some point, this will have an input and will have an impact. And vice versa, the demonstration and field test projects have to publicize their results. We've discussed that in the context of the joint undertaking several times, I believe, that there's too little feedback. And that, I fear, is happening with these very large investments again. So 100 megawatt electrolyzer, what does that mean in research topics? And how will that survive in an environment that is currently not made for it? But I'll come back to that in a moment. So there's a lot of difficult questions to answer here. A lot of it is materials research. I'll come back to that in a moment. And with materials, you're trying to marry properties that are in conflict. So you want low degradation, high performance, long lifetime. You want improved robustness. You want good handling and processing, so manufacturability. And you might get great materials, and I always hear these people saying they have something very promising. Next thing you know, you can't apply it. So you want to make a ceramic and it just doesn't sinter. So no matter what the great properties are, it doesn't react with sulfur, whatever, you can't make a component from it. So who cares? So all these things have to go together, and you need both industrial and university input to this. So you start with this promising material. So here, this French promising material. You look at the processing properties, it doesn't work, you have to modify it, you have to go back to processing tricks, you get composite materials and some functional improvement where you've done lots of compromise on the way. But what has to happen here is research needs the input from industry. So we always said when we transferred something to industry, you have to keep talking to us, and they never did. They went away and then stopped the development because it didn't work, and we might have made it work. So if you look at all the development aims, the stuff that has to happen, and it doesn't matter whether it's a fuel cell or electrolyzer, it's all the same, or any other hydrogen equipment. You need long-term stability, thermodynamically, chemically, whatever. You need high performance, so very porous, very intricately developed materials, all kinds of properties, all kinds of materials acting together. So typically we have a variety of different materials working together, quite different to other technologies. And most of that is materials development. And a lot of that input comes from science and universities and research institutions. And right at the bottom, we have something that is more engineering, operational strategies, how to keep the system happy, how to let it survive a long time. And I just pulled this up while I was researching. I don't want to go into detail here. This is a slide we prepared in 2007, and it's just as true today. So with a lack of integration between industry and research, you just don't progress sufficiently. And I must say, in this case, it's SOFC. The SOFC scene in Europe is very much interconnected. I was part of interconnecting them in 2004 when we started the project, Real SOFC, and people are still talking to each other. It's getting more commercial, so people are moving off into different directions, but this still is a sort of scene. Now, there is scientific ways of getting out of this, and a lot is about the materials. And it's not just about materials, mixing different alloys, it's also about understanding the materials. I still ideally think of a project where we can model materials, we can model them to purpose and predict how they will work and then synthesize them. I actually tried that once, it didn't work too well because actually you couldn't synthesize what you modeled. You just physically couldn't do it, and the models didn't tell us that. But from a better understanding of materials, we can get better components which give us more lifetime, and lifetime is an issue with all these technologies. And more performance, and you just name it, reducing costs, improving the manufacturability, all these things. Now, let me just look at another aspect which I think is very important. That is the regulatory and economic framework. So what I predict, and that's why I think we're in a hype cycle, is that a lot of people are now investing a lot of money, or a lot of public money, I must say, unfortunately, into very large projects. The next thing that will happen is they will say, oh, oops, this is expensive. So typically when talking to shipping companies, there's a huge interest in hydrogen until you start doing the math of what it will cost. Because currently, of course, hydrogen has the benefit of being environmentally benign and being pushed by everybody, publicly and politically, but it can't compete with the fossil energy carriers. You can't compete at the basis of a diesel price. It's just not possible. So if you tell people, well, it will cost the four times or 5 times more than maritime diesel, they won't be interested anymore. They will be prepared to pay 10% more. And I've actually worked on projects where we could come up with double the price, and that at least you can discuss that. So the lack of level playing field just destroys the economic perspective. So there won't be immediate customers. So initially customers will say, yes, we're interested until they see the price. So talking to logistics companies, if the price is even more, anything more, they will not be interested, at least not seriously, because Amazon has been putting pressure on them to be green. So they have to do something, but will they invest into a hydrogen lorry if they see the price? So a tractor will be 500,000 euros instead of 150. So where will this difference come from if nobody pays it? So there will be a lack of follow-up investments. We'll have a 100 megawatt or 5 gigawatt electrolyzer, and then what? Where does the hydrogen go? What is the price of that hydrogen? Who will absorb it in the market? I can think of many things, but the regulatory framework and the economic framework doesn't support this currently. So what we first need to do, and that was this building block falling off the top, if there's no regulatory and policy framework, then this will fail. So Germany has just done one of them by getting rid of the renewable energy levy on electric power that is being used to produce hydrogen. The next thing we have to get rid of is the grid levy, because that completely destroys the prospects of taking green electricity off the grid and producing hydrogen. If you're not situated in the wind farm and can use without the public grid, no chance. And just to illustrate this, so something I did years ago, just take this as the cost of a prototype hydrogen vehicle. First prototype 100%, then coming down, building a couple prototype, and then trying to get into the market. Everybody will say you get into the market when you're the same price as a normal vehicle. Next question is, what is a normal vehicle? Could be an expensive one, a Mercedes, it could be a cheap one, a Fiat. And then, of course, the comparison is on the purchase price, but that is not the comparison. The comparison is on the operating, the full cost of ownership, so including the operating cost. That would be this line. So you can see what difference that makes. You can subsidize the hydrogen vehicle, price comes down here, so you actually get an earlier intercept. But that is not the right comparison. The right comparison is the diesel car, the Mercedes, with no emissions. So put on all the chemical plant you need to get rid of the diesel emissions, and that is the comparison. This is not a level playing field. And then you can discuss whether you do that regulatory or subsidy. I would by now vote for the regulatory approach, like not letting internal combustion engine vehicles into towns like London. You just charge them. So now we have this dominance of large-scale projects. So what we actually need is the feasibility proof of technology. That is what I call field tests, and the field tests with publicly available results. So what is the experience with the technology? Demonstration projects have been used to spark off developments, but this doesn't always work, as I showed with the Qt project. So one result or one insight of this is there has to be several projects of the same kind. So often enough in national or international programs, we find one project of a certain type is funded. There is no funding for further projects of the same type because it has been done already, but it's been done by one company, not by several. And I talked about the Qt already. There just has demonstration as such. These very large scale demonstrations might not deliver the goal because they're singular and they don't have the economic basis to then exist on their own. So learn to walk before you run. So there has to be a broader supply basis. There has to be more people funded for doing the same and having a variety of technologies. So a competition of solutions to the same technology. And that then gives things like next gen or the game changer we're always talking about, or the disruptive way of producing something which is so much cheaper. And just at the bottom to point this out, it was mentioned somewhere, I think somebody asked that in the chat, there should be more cooperation with other areas of society and technology that are changing, or infrastructure. E-mobility, I wonder, might have an impact on how we travel, on mobility as such, on mobility services. And that is something we're taking on board too little. So just to sum up, so I'm not using too much time, I am anxious that we are in a hype cycle, and we have to just make sure that the money we're investing will be well invested. So in order to avoid disappointment, we have to have a base of research. There has to be a lot of inventiveness going into this, and we have to see to it that this is funded sufficiently. We need a regulatory framework that will support all these developments so that the economy is solid, even if it's by regulation, and so that we get sustainable business cases. If you can only go into town with an electric vehicle, which is a fuel cell vehicle, so be it. There's no question whether it's economic. It's the only way you can go. And there definitely is scope for public funds to go into this, and it doesn't always have to be subsidies. It could also be loans or guarantees, but maybe not for the really very large demonstration projects. So just to finalize here, I'll leave this slide up maybe and just point out a couple of events we're running. So there's the summer school in September, which once started as a EU project trainee. There's the master's course we will be starting in October, Teachy. There's Lucerne conference we support, and the workshop we will be running in Bruges in May, hopefully in person. So I'll stop sharing and I'm open to questions.
Thank you, Robert, very much. This is exactly what I expected from you when I invited you.
I just have to open the door for a cat.
Yes. I worked on both sides. I worked in the industry and I worked in at universities, so I know exactly what you were talking about the product development and market readiness and investments. This was just excellent. There's a question. I don't know if it is appropriate. Let's see. Could you please share your thoughts on the role of hydrogen in the decarbonization of heavy industry?
There's a huge potential there. Yeah. But it's exactly what I was pointing out. Once they see the cost, will they still be interested? So if we don't have a framework of where we increase the price of carbon dioxide certificates, this won't fly. There's a huge potential. Yeah. Steel industry has told us 3 years ago, you can build as many electrolyzers as you like over the next 20 years, we'll buy all of them. It remains to be seen that that is true, but if you take industry, and essentially it's chemical industry, hydrogen is the input to chemical industry in many applications, the demand is huge.
Okay. I don't see any. There is one in question and answers. I'll answer that one myself. Okay. So you think the future is bright for hydrogen?
Yes, in a way. Let's say hydrogen offers solutions to many problems we have today. And it's not only hydrogen as such, it's also what I call hydrogen-based fuels. It could be ammonia, it could be methane built on hydrogen, so synthetic natural gas with biomass carbon dioxide. There's many ways you can package the hydrogen. It doesn't have to be hydrogen as the pure element. it offers a lot of solutions if you set the policy and the regulatory framework properly. If that is not set properly, a lot of projects will fail because they recognize they're far too expensive and they can't deliver into the current economic situation. As long as you're competing with diesel prices are currently going up, at least in Germany, because of carbon taxes. So that's the right thing to do. But at some point, you'll have yellow vests all over the place, people complaining about fuel prices. So you have to package the whole thing. We are currently paying for the environmental damage through our taxes. So if you avoid the environmental damage, you can invest that money in other places. So it's a zero balance. But politics have to set that balance and they have to show that it works. And until that has happened, I find it relatively bleak as an outlook.
Okay, thank you very much. Let's go further. Next, I asked my colleague, Neven Dujic, to tell us about the energy transition in general and specifically for Croatia. So Neven, the floor is yours.
Thank you very much, Frano, and I would also like to thank very much Robert for excellent pointing out what are the problems on the way towards hydrogen economy, and I will try to see how, or I will try to say what we see from the side of energy systems, where we see hydrogen coming and when, regarding the speed of energy transition. 2020 was a very interesting year. It was partially thanks to Corona also, but not only. The first year in which for a long time clean energy sources were bigger in production of electricity on a global scale than coal. So what we see in European Union is that clean energy sources, especially wind and solar, are growing very fast, and that today wind is already the biggest electricity source on the capacity level. What International Energy Agency is predicting is a very fast collapse of coal in the next 5-6 years in European Union, and a huge growth in renewables, variable renewables, primarily wind. Solar is not something that the International Energy Agency still recognizes, but I think it will be much faster than it's shown in this graph. So if we look at last 12 years since 2008 energy climate policy, European Union has done wonders. We more or less managed to get to 20% of renewables in energy systems. And if you look at Croatia, Croatia was particularly successful. We already managed to reach the goal by the 2005. So we are way above the level. Let me show you here, Croatia, above our target. So we are quite successful in renewables. So what we will see in the next 10 and 30 years, it's quite a big revolution in energy. We want to reach climate neutrality by 2050, which means that fossil fuels will be mostly out. On a figure, you can see the phase out of coal happening quickly around Europe. By 2030, we want to reach 55% lower greenhouse gas emissions compared to national transport, and decarbonization of heating will also be necessary. There is an idea to stop all investment in new fossil fuel infrastructure after 21. In order to reach that, we have to reduce emissions in sectors according to this green line, because agriculture is complicated. We have to do more on the power side, on transport side, the green line, really revolutionary goals that we put in front of us. And in a way, because variable renewables, solar and wind, are now very cheap compared to fossil fuels and nuclear, we probably will go into direction of mostly using those sources in the energy systems. But that creates a problem due to the variability or intermittency of those renewables. We will, of course, need more grid interconnections. We will need to flexibilize thermal power plants in a short term. We need wholesale markets coupling, which will make everything cheap. But the most important thing, we have to start integrating power, heating, cooling, transport, and water systems, creating huge amounts of demand response of the power to X technologies. Because dedicated electricity storage is something that will be quite expensive. We have to find much cheaper energy storage, and that can be done by integrating various sectors. If we look at wind and solar capacities in production potential in Europe, we can see that we have a problem with solar because we are quite north. So we cannot completely cover our needs with solar and short-term storage. We need wind, and the best combination of wind and solar shows that we need probably 2 times more wind than solar. If we build enough wind and solar, we could cover most of this of the electricity need, which is the red line here, with wind and solar, because on a continental level, they balance each other enough that we have at least 10% of wind at any time of a year. So in that case, we will come out with a huge excess of wind and solar, which are available for other uses. Of course, this is extreme position. We will, of course, use other renewable technologies and probably some nuclear. But I'm just wanting to show what happens with variable renewables. What to do with these excess renewables, which we can not produce, but then we lose money, or we can try to produce it and sell it and use it in some way by supplying demand in heating and transport and industry. How to do it? 20th century energy systems were simple. They were based on supply follows demand. 21st century energy systems must be completely opposite. We need energy of using this excess electricity in power to heat. This is a small district heating in northern Denmark. And in times when electricity is expensive, it's a pale green line, then cogeneration units turn on and produce electricity and produce heat, store heat in heat storage. In times when electricity is cheap or even negative price, electric boilers turn on and they cover the heat demand and also spend excess of electricity in a usable way. We could cover much more of the heating with heat pumps, but we need also heat storage. Heat storage is extremely cheap compared to electricity storage. So it makes more sense to go with heat storage than storing electricity and then retrieving it back again to produce heat. Also, transport is quickly electrifying. 4% of the market in the last year were electric cars. It was around 3 million electric cars, and it seems that this is going very quickly now. European market is already 10% electric vehicles. Croatian market is 2% electric vehicles. So it seems that for short distance personal cars, electric cars, battery electric cars have won the battle. This electric mobility has an issue. Let's imagine a very extreme situation that everybody comes home at 5 o'clock p.m. Everybody has a fast charger at home of 70 kilowatt. And on Austrian case, let's say 4 million cars arrive home, plug in, and we get 280 gigawatt of power demand, which is around 20 times more than installed cap. So this is not possible. Of course, this is extreme and it will not happen. But on the other hand, cars are parked 96% of time. So with smart charging, which is market-based, we can smooth the demand. So if we look at just those two technologies, power to heat and power to e-mobility, we can significantly increase penetration of variable renewables. On wind, if we increase the penetration of wind, we get more and more of critical excess of electricity production, which means rejected, curtailed electricity, which cannot be integrated. At around 20% of wind penetration, we get around 5% of rejected electricity, which is the limit of economically viable share of wind penetration. If we add power to heat, we get to 40%. If we get power to e-mobility, we get around 80%. So we are still left with 20% that we cannot solve with these problems. Why so? Road freight, we have several options. Roads can be electrified, or we can go for hydrogen, or we can go for some other e-fuel. Shipping and aviation long distance cannot be electrified and probably will not be. High temperature processes, sometimes that cannot be electrified. We will have winter windless weeks when we will need backup. They don't show very often, but they may happen. So, it makes around 20% of energy demand. If we use biomass in a sustainable way for maybe half of it, the other half has to be covered by something else. And what we see as, and what everybody sees, it's hydrogen or some other kind of e-fuels that we cover this demand. We did simulation of Southeast Europe in 2050. It's published on Applied Energy. I will not go into detail, but what can be noted is that we see that primary energy will actually fall to half. Quite a lot of it will be, most of it will be variable renewables and renewable heat, and quite a lot of biomass, since region is quite rich with biomass. But electrolyzers will actually spend half of electricity. So even though they will cover around 10% of the final energy use, half of the primary energy will go to electrolyzers. This is the cheapest way how to fully decarbonize energy systems, even though Robert was speaking about hydrogen being expensive. This is the electricity generation mix. We see quite a lot of PV, winds, but also hydro, since the region is quite rich in hydro. So what is the way for hydrogen? We can see now in Europe two different visions for hydrogen. One is to decarbonize gas and fuel by replacing it with hydrogen and synthetic fuels. And what we could call efficient way is what European Union in its strategy calls hard to decarbonize sectors, where other alternatives might not be feasible or have higher costs. So let me look a little bit into those options. We were talking about heating and using either hydrogen or maybe e-fuels for heating. Does it make sense? If we use electricity coupled with heat storage and heat pumps, then we need around 1.6 terawatt hours of electricity in the Union. If we produce hydrogen by electrolysis, and then store it, transport it, we probably need something like 5 times more primary energy from renewables. If we go to e-methane, synthetic methane produced from green hydrogen and green CO2, we need 10 times more. So I don't really see hydrogen in heating because we can easily cover all the heating needs, low temperature heating needs, with electricity and heat storage, district heating, and heat pumps. But on the other side, in road transport, we have a bit more complicated issue. Yes, electricity is most efficient way to deliver transport, but because of energy density of batteries, which is rather small, we will not be able to electrify up to half of the transport. And then we will have to use either hydrogen pathway, which means around double more electricity from primary energy, or we will have to go to synthetic fuels, which will then mean even more, 7 times more electricity from primary energy if we go to e-DME or e-methanol or some other option. So what we see as a good solution, there will be Paretos dividing electricity and fuels, which means that short distance transport will mostly be covered by batteries, and long distance transport will then have to sort out which of the hydrogen or other hydrogen-based fuels will win. We don't see winners yet because it will depend on many things Robert said, regulatory and who will invest in infrastructure. It is not really that clear. But probably half of the transport will need hydrogen or some kind of hydrogen-based fuel. So what we can conclude about the energy transition is that wind and solar are going to be the main energy sources, primary energy sources of future. Around 98% of the investments in the last few years was in wind and solar in European Union in the power sector. But they're difficult to integrate. And that's why we need integration of power, heating, cooling, water, and transport systems. And the new integration strategy has correctly shown the way. We will need smart energy systems, which will be cheap and simple. What we need is green hydrogen because of two reasons. One reason is because we actually want to decarbonize those sectors. If we use gray hydrogen, it means we are not decarbonizing sectors. Also, we need green hydrogen because this is the cheapest way how to finish the energy transition. Without green hydrogen, we cannot close the whole story. So what we actually urgently need from developers, from companies, is cheap electrolyzers. We have to push the price of hydrogen to 1/3, 1/4 of the current one of the green hydrogen, so it can be competitive with gray hydrogen, and it can easily replace gray hydrogen in industry, and then slowly move it to the transport sector. Thank you very much.
Thank you, Neven. Me and Neven have numerous discussions previously at the conferences, now mainly online, and we in general agree, except that he is probably too optimistic about the batteries in my taste, and I'm probably too optimistic on hydrogen in his taste. But in general, we agree on this energy transition topic. Are there any questions on this? I don't see any. On the energy transition, I think that's I think you got covered all the aspects of energy transition and the role of hydrogen in it. And I will now announce myself, because I will try to continue with this energy transition and the role of hydrogen, but specifically what can be done in Croatia. So let me share the screen. And I have to move to the beginning. Okay. Okay, so the title is Opportunities for Hydrogen in Croatia, Energy Transition. I don't have to present myself. I think most of you know me. I'm now retired at university, but I'm actually working more than I was working before, and mainly on the projects. That shows that there are many projects now on hydrogen, even in Croatia. So very shortly, what is energy transition? Neven already covered this, and what role hydrogen should have in it. Also, so I will mainly concentrate on this third part, what can be done in Croatia. So energy transition is a transition from, let's say, a fossil fuel, primarily fossil fuel-based energy system to renewable-based energy system. And the reason for this transition is carbon dioxide and the global warming. So this is an EU view on hydrogen's role in energy transition. Jorgo mentions most of this, but he didn't show, I think, this slide that shows what are the roles that in the EU view hydrogen should or could have in this transition period, and also in the energy future. First of all, is enable a large-scale, efficient renewable energy integration, and then distribute this energy across sectors and regions. Sectors meaning not only for power supply or electricity supply, but also in transportation and in heating. And then also, and that way act as a buffer to increase the system resilience. But at the end use, the hydrogen will have a role in to decarbonize transport, to decarbonize industry energy use, and also serve as a feedstock in some industry that use hydrogen, and that hydrogen is now being produced from natural gas. So if we replace this gas with a green hydrogen, that will also contribute to decarbonization. And then in heating, hydrogen can decarbonize to some extent. We asked this question to Jorgo, and he thinks there's a lot of opportunities for hydrogen. I kind of tend to agree more with Neven. I don't think that the hydrogen has a lot of opportunities in the heating. So hydrogen has become a hot topic, or Robert used the word hype, There are daily news on new developments, new business ventures, new plans. There's a new magazine called High View that actually publishes all the developments in the hydrogen business, the hydrogen industry. And on a daily basis, on a daily basis, we have news. This is just the news from the last 2 weeks, showing what's going on in industry, who's making deals with whom, who develops something, who plans to develop something, and so on. So it's very interesting to follow this. And this reminds me on a hype we had before. You know, I've been in the hydrogen business for so long that I've already been through hype of hydrogen, and there was a very similar kind of news and news forums for hydrogen. So this is all part of hydrogen hype. Okay, so now what can be done in Croatia? And this part of my presentation, I will first talk about the Croatian present energy system, then mention the Croatian energy strategy till 2030, role of renewable energy, role of hydrogen, present level of involvement in hydrogen technologies, briefly about Croatian Hydrogen Association, increasing interest in hydrogen in Croatia, and then about Croatian hydrogen strategy. So this is a very simplified diagram of the Croatian energy system as it is today, which is primarily based on imports of natural gas and oil and some coal as well. We have domestic resources of both wood and biomass, natural gas and oil, and then we have hydropower plants and wind and solar power plants. And also we have 1/2 of nuclear power plant, which is at the border with Slovenia. We also import a lot of electricity, and we use this in a traditional way, showing this is a residential commercial sectors in industry and transport. So this is, Croatia is relatively good position because it has a lot of energy provided from hydro, also from some wood and biomass. And so reaching the goals, as Neven has shown, of decarbonization was fairly easy for Croatia. So this is how much renewable energy we have. We now have, I was really surprised when I found this data that we almost have about 1 gigawatt of installed capacity from renewables, mainly from wind, but some solar, small hydro, biomass, biogas, and also in Croatia they count cogeneration also as a part of the renewable. This is actually showing only the generation that is in a system now of let's call subsidies, but there is also some of them that came out of those subsidies, and they are not counted here, but they are maybe in the order of 20, 30 megawatts. And this also shows the generation in December from this, so mainly from wind, biomass. Solar is very small because December was probably not the best month for solar, and also there may be some new solar power plants coming, counting here, but not really coming to full work in December. Croatia has an energy strategy up to 2030 with the outlook to 2050. And we can see there that currently Croatia has a 27.3% of in the baseline share of renewable energy in the final consumption, or 45% in electricity generation. And the goal is to increase those shares to 2030 or 2050. S0 is a business as usual. S1 is a very rapid energy transition, and S2 is a slightly moderate energy transition. And in all of them, we plan to increase the share of renewable energy in the electricity generation up to 80, 82, 88%. In the final consumption, relatively modest, 37% by 2030, or 65% or 53%, depending on the scenario. Also, the share of electric vehicles on the road up to 30% in a business as usual scenario, but up to 85% or even 65% by 2050. Renewable energy. This is the types of renewable energy that are in the Croatian energy strategy. and it looks like this strategy was trying to satisfy everyone. So there is a hydro, there is wind, there is solar, there is biomass, biofuels, geothermal, and Croatia is really blessed with all those resources, and it should use them to be energy independent and to be clean. This is in the power generation. So again, we have a solar, which is yellow, and wind, which is green, which is predominantly by 2050. We also have a hydro that is now, Croatia now is generating about 40 to 50%, depending on the year, from hydro. And with this, this is from also everything from the energy strategy of Croatia. We plan to accomplish reduction of CO2 emissions by 2030 in the order of 35 to 37%, and by 2050 by 64 to 74%. And hydrogen is not mentioned in the strategy. Well, it's mentioned, but very, very shy, and there are no really numbers or goals. So European Union has launched a study for each country member for hydrogen opportunities, and they consider our energy strategy, they consider opportunities in Croatia, and these are the results. What came out of this study is that there is a potential for up to 2030 to employ 26 to 150, depending on the scenario, megawatts of electrolyzers, and then use this hydrogen in industry, in buildings, in transport, and in power as a load leveling. So this is much more aggressive, let's say, thinking than a Croatia energy strategy. And I went even further. With my students, we kind of envisioned 100% renewable energy system for Croatia in 2050. And it's very easy to put this on the paper. We have to satisfy our needs for electrical energy, for heat, and for transport, and we only rely on the photovoltaics for solar power plants, on wind and hydro, and therefore use electricity as directly as possible, as much as possible, use heating for the heat pumps, either electric or gas powered, and use hydrogen as a storage medium and also as a fuel for transportation. So half of it will be on hydrogen, half on electricity, and then also use hydrogen to produce synthetic methane that can be used then, because there's existing grid of synthetic methane that can be used also for in a power generation, cogeneration, or in the heat pumps. And this, so this shows that it is possible to have it. The question is how to get there. Just a brief overview of the current activities. This is actually Bart Weibuch's slide that shows hydrogen activities in Croatia. Very few. We have INA in Rijeka that produces hydrogen for its own purposes, but it has a capacity reserve that can produce more hydrogen if anybody will be buying it. So far, there are 4 projects that were funded by Fuel Cell Hydrogen Joint Undertaking, and all 4 we have here at the Faculty of Electrical Engineering, Mechanical Engineering, and Naval Architecture at Split. This is my research group. We also, outside the project funded from FCA-JU, we built a complete hydrogen energy system, and we have a fuel cell power ATV. And then my colleague at the University of Zagreb also is active in the hydrogen field with the fuel cell bicycle and a hydrogen refueling station using renewable energy. So this is the energy system that we have at the university here in Split. We have a photovoltaic panels on the roof, a wind turbine on the roof, and providing a DC or AC loads. This is in the lab. And then the excess electricity can go to hydrogen. We can store hydrogen and then use it to refuel the vehicle. We have this Yamaha ATV. Or when there is no wind and no solar, we can then produce electricity from fuel cells. And the system, of course, has also batteries for a short-term storage, and the hydrogen is more like a long-term storage. So this system is actually already in place for several years now. We have a wind turbine that actually last Bura broke it. so we have to buy a new one. Photovoltaic panels have been moved to another location, but still are working here on the roof, and they are all connected to the lab. And in the lab, we have a fuel cell, we have the electrolyzer here, and the DC-DC converters, and the electronic load is here, and the hydrogen storage. There is only one bottle now, but we already purchased and is being installed as we actually speak, 12 bottles of hydrogen in front of the lab. Last year, or actually a year before, we started the Croatian Hydrogen Association, which was actually, I started this as soon as I came back from the United States. That was in 2007, 2008. We started, but it was ahead of its time. It was mainly dormant because there was no interest for hydrogen. But since we noticed that there is an increased interest in hydrogen, we revived this organization, and we now have we have become a member of Hydrogen Europe and the Clean Hydrogen Alliance. You can find us on this map. This map also Jorgo showed this morning, and this is the logo of Croatian Hydrogen Association on this map. Our mission is to provide the support to hydrogen technologies and their developers and users, leading to their implementation, thus contributing to cleaner environment and sustainable national economy. Our activities more on the promotion and popularization of hydrogen energy technologies, connecting research institutions with industry and government bodies in creating projects involving hydrogen energy technologies. I will show some of those projects that are ongoing. Interacting with the international organizations with similar mission. As I said, we are part of Hydrogen Europe. And contributing to creation of the national hydrogen strategy. Our members are big players like INA, HEP, Đuro Đaković, and Siemens, and the small businesses like Adria Wind Power, Active Solera, and Ixoy Green Systems. We also have companies that show interest in the projects like Brodosplit, the shipyard, Messer, Cemex, Sem Marine, Pomac, and InnovaPro are also members of our association. This is a list of possible hydrogen applications in Croatia. Firstly, in transport. So we can have a city and inner city buses, trucks, trains for non-electrified rails, delivery vehicles, vehicles for cleaning and garbage removal from city centers, forklifts in industry and warehouses. All these vehicles already exist in the market in Europe. Specifically for Croatia, we need vehicles for transport of tourists to the beaches and hotels, vehicles for tourists in national parks and natural reserves, including boats, and also boats, ships, ferries, small cruise ships. Croatia was once a world between 3 or 4 leading countries in shipbuilding. We have mainly neglected this, and I think this is an opportunity to maybe revive some of them if they can focus on hydrogen-powered boats, ships, ferries, or small cruise ships. But the problem with the hydrogen in transport or hydrogen, any application of hydrogen, is in a hydrogen chain, is interdependence of hydrogen technologies. Because introduction of hydrogen technologies requires involvement and coordinated action of hydrogen producers and distributors. You cannot buy a hydrogen bus because there is no hydrogen supply in Croatia. And nobody is supplying hydrogen in Croatia because there are no hydrogen buses. So that's why I said that we need a coordinated action between producers, distributors, manufacturers of devices and equipment, vehicles, and end users. And in addition, a regulatory framework, we already heard a couple of presentations before, must be in place and the financing secured. So there's a lot of work. It's just an idea. I will put a hydrogen bus on the road because you have to solve all these issues here. So yes, for all these vehicles, we will need the hydrogen refueling stations and hydrogen supply infrastructure. And this is a possible hydrogen refueling network. About 5 years ago, Ankica and her professor, Mihailo Firak, they published a paper about the hydrogen infrastructure that is possible to produce hydrogen through electrolyzers and have numerous refueling stations along the main corridors. So maybe in the beginning it will look something like this, and maybe in the end we can produce hydrogen at these fields and have hydrogen refueling stations in these red dots. Also, we can use hydrogen generation for storage of energy from renewable energy power plants. We can use fuel cell cogeneration units, or use green hydrogen in cement and petrochemical industries. Or we can, if you don't know what to do with hydrogen, we can inject it in natural gas pipeline system up to a certain percent. Croatia has a natural gas grid that has been extended even further to the south. But there is a problem in the south because there are no users and there are no distribution grids. They are being built. We have a lot of roadworks now split by putting the natural gas pipelines. But I think the better option would be to put a natural gas fuel cells near the major pipeline, and then rely on the existing electricity grid to provide hydrogen. And also we have one project that is ongoing, which is somewhere here near Zagreb in thermal power plant Jertovec, that is going to be decommissioned. But instead of using natural gas, it may be producing a green hydrogen and injecting in a grid of natural gas. So this is the list of recent hydrogen-related projects at the various stages of development. Some are just the ideas, some are really going on. Actually, today at 10 o'clock, there was an announcement of city buses and the refueling infrastructure in the city of Zagreb, which is a project that I'm proud to be a part of it. City of Zagreb and INA are developing this project with the PDA. Bart mentioned this as a project development assistance that they got from Brussels. Similar projects we would like to have with the postal service vehicles, again involving INA and the Croatian Post Office. There is a project I just mentioned in the previous slide, the green hydrogen generation and injection in natural gas pipeline. There is a project about the wind farm load leveling using electricity from a wind farm when the price of electricity is low. And then instead of selling it for the low price, they can produce hydrogen and then selling either hydrogen or selling electricity at a higher price at a later time. Hydrogen for decarbonization of energy in cement industry. I just recently learned that Cemex is going on with this pilot project. Actually, there was an announcement in that Hydrogen View journal that I mentioned before about the cement industry doing this, and I sent an email to Cemex, and they said, yes, we are doing it. We will let you know how it goes. Then there's an idea to use a boat between the airport and the city harbor and equip it with the fuel cells and batteries and have it as a hybrid. And the same company also can produce its own hydrogen from a solar power plant in a split background. And then also there's an idea of using hydrogen, producing hydrogen from garbage, and we will have two presentations later in a second part of this webinar. So in the conclusion, hydrogen can have several roles in the Croatian as well as in European energy transition, which is enable large-scale integration, renewable energy integration, and distribute it across energy sectors and act as a buffer. Also to help decarbonize transport and help decarbonize certain industry as a fuel and as a feedstock. There is an increased interest for hydrogen in Croatia as compared to maybe 10 years ago or 5 years ago or last year, a tremendous increase in interest. And we definitely need the Croatian hydrogen energy strategy to take advantage of the EU hydrogen strategy that Jorgo mentioned, and to create opportunities for hydrogen in Croatia. And I have a breaking news here, because last week Croatian government has made a decision to make a national hydrogen strategy, and the working group has been proposed. And the next presentation, Akita will tell us more about this. I'm sorry if I took under from your presentation, but this is all I have for you. So I'll be happy also to answer any questions if there are questions. Okay. is one question here. How are the Croatian regulations regarding hydrogen transport and storage applying to European regulations? I think I can answer very briefly. We don't have a Croatian regulations, and so we, in the cases where there is no Croatian regulation, we then use European standards and European regulations. Any other question? There is maybe one in question and answers. Until now, I heard only about electrolysis as a methodology for hydrogen production. However, some other concepts are under consideration, at least in the scientific community, such as photoelectrochemical or photochemical water splitting. Are these concepts considered as potentially viable technologies in a real-world system? The answer is very simple. Yes, if they can meet the cost targets. Those are very attractive systems to produce hydrogen directly. So instead of producing electricity and then using electricity to split water, yes, we can split water directly in some device that looks like a photovoltaic panel, but instead of electricity, the product is hydrogen. But it must be efficient enough, or who cares about efficiency? We care only about the cost. So if the cost is acceptable, and the reason why Europe is putting so much emphasis on electrolyzers is there's opportunity to bring the cost down by mass producing. There's a Moore's law that any product can, if it's produced, if the production is increased by an order of magnitude, the cost goes down by half. So that's why European Union is setting this goal of 2 times 40 gigawatts of electrolyzers, hoping that the price will fall down by 4 times. Okay. There is no more question, and I will ask then Ankica to tell us about the hydrogen, Croatian hydrogen strategy. Ankica?
Yes, I'm coming. Just a second to share my screen. Do you see my screen? Do you hear me, Professor?
Yes, we can hear your screen. Okay, we can see your screen and we hear you.
Hi, good afternoon, everyone. I will give you a few hot information on Croatian hydrogen strategy. What is the most important? Regarding to the European hydrogen strategy that was published in July 2020, there are 2 main points. The energy transition to renewable energy sources is urgently needed on a large scale, and it can be accelerated by relying on mass-produced green hydrogen. So we need mass hydrogen production to secure green energy transition with 0 CO2 emission. So when it comes to the production of green hydrogen, regardless of the power of the plant, according to the European hydrogen strategy, the choice fell on water electrolysis. So hydrogen produced via water electrolysis using renewable energy sources is so-called green hydrogen. And this is important to highlight all the time, that only accepted on the long way is green hydrogen. So we have a historical date, February 25th, 2001, when on the proposal of the Minister of Economy and Sustainable Development, Tomislav Ćorić, the government of Republic Croatia, headed by Prime Minister Andrej Plenković, adopted the initiative for development of Croatian hydrogen strategy. I think this deserves attention of all of us in Croatia, because I would say our big dream is coming true. I'm really happy that Croatian government recognized the importance of hydrogen and the importance of developing a hydrogen national hydrogen strategy, because on this base we would apply on some fundings when you have some vision on the base of hydrogen strategy. Then you can develop your project, and then you will achieve your results based on energy transition without CO2 emission. So what are the hottest information from the ministry? This is that in the next 10 days, an expert working group will be established. The expert working group starts working on the day of its establishment, and this document is expected to be completed in the next few months. So this should not and will not take years. It will take just a few months to complete the document. So from this strategy we can go further to have some active plans and to really work and adopt hydrogen as energy carrier within Croatian energy system. So Professor Barbir already showed a few of these figures. So what can I say? The great minds think alike. So I will just quickly pass through these figures. Here is presented gas network pipelines and solar irradiance in Croatia. Croatia is very rich with solar energy, and we are still not using the whole capacity of solar energy. But I'm pretty sure that this will change very near in the future, especially now when we have started with Croatian hydrogen strategy, where we will focus on the green hydrogen and its production using renewables, mostly solar energy and wind and others when appropriate. So this is just a solar irradiance and electro distribution network of Republic of Croatia. And as Professor already mentioned, we analyzed 3 phases within this paper. So this was the first phase where we planned a hydrogen refueling station in the three big cities. The second phase included other cities, and the third phase is covering almost the whole Croatia. And hydrogen refueling station can be installed with hydrogen production on site or off site. So it depends on solar energy when we where we locate hydrogen refueling station. And it is not just about hydrogen refueling stations. All this system is in fact energy system where you can supply household, industry, and everyone with electrical and electrical energy and heat energy as well. So how we will achieve all these results and our ideas and plans just in this way. So to become climate neutral by 2050, we need to act together, and this together means academy, industry, and the policy. And I think we are on a good way. We are doing good things, and there are more good things are to come. So we just need to keep these three wheels together. So it's to highlight today's webinar. So it is not all about hydrogen. We are not talking about hydrogen as a purpose in itself. Here is all about climate change. So we don't have a time. By 2050, we need to have zero emission. And there is no space to further discussion why we have time. It is a long term to 2050. No, there is no time, and we have to act now. And the hydrogen is here a source to help this transition to achieve climate neutral Croatia, and not just the Croatia, but the whole Europe with zero emission by 2050. And without comment, it's just a full stop. Thank you very much for your attention. If you have any question, I'm here to answer. I don't see if there is any. So, Professor, you can read or.
Thank you, Ankita, for this brief introduction of Croatian hydrogen strategy. We are all very proud, and I also thank you for all your effort to actually get there, because things don't happen by itself, I know. So this was the first part of our conference that we have invited talks, because I envisioned this to talk about European strategy, about development of hydrogen in Europe, and then about the Croatian transition and Croatian developments in hydrogen and Croatian strategy. Now, for the second part, which will be much shorter, we have 5 or 6 presentations on different projects that are being envisioned in Croatia. And the first one of those is a project I mentioned, or actually I mentioned all of them in my presentation, but the first one I mentioned was the bus project in the city of Zagreb, but there's actually much more than this. INA and Damir Miletić from INA will tell us about INA's perspective on hydrogen in Croatia. So,
hello,
Damir? Yeah. Okay.
Hello, everyone. My name is Damir Miletić. Thank you for this introduction. I'm a head of INA development, and I'm glad that I will present you our project, what we are developing yet. Okay, just to put it in the slideshow mode. Okay, I will talk to you about this project, about the concept of this project, where we are now, and what are the next steps. But first, let me introduce with the INA. So we are medium-sized European company owned by 2 major shareholders. We have a upstream part, this exploration and production of the crude oil. We have a processing now in the Rijeka refinery. Only Sisak refinery we are transforming in industrial site, and also we have now more than 500 filling station on the core market. What about the project? Our aim is to evaluate hydrogen as an alternative fuel in transport. We see and we saw all reasons why the hydrogen is inevitable in our future to the path is a path for the decarbonization. And our main interest is to use the hydrogen production in the Rijeka refinery and develop one green hydrogen production either in Rijeka or Sisak refinery. Now we are making the different studies to see what option is the best. So what is the benefit for INA and interest for INA is that to offer the hydrogen in the market for the reasonable price, to be competitive, and for the long-term development of hydrogen economy, because as you all see, in these presentations before, that it will be the major supplement for the diesel in the future. We also want to contribute to Croatian energy strategy in decarbonization in transport. So this transformation to green and low carbon energy, this is also something what we want to used to be on that train in the path of our transformation to greener company. So what about the project? So idea started with our hydrogen production. What we have in Rijeka, we have a big surplus of hydrogen produced by steam methane reformer. This is technology very conventional. We also produce the electricity and steam on that unit, but this is since this process is very CO2 intensive, we want to decarbonize. So our major interest, besides the selling the hydrogen as a transport fuel, is also to consequently use it as a feedstock for the refining process. It will also depend on the price of the CO2, but we want to be prepared for this scenario. So besides the steam methane reformer, we want to install the electrolyzers from renewable energy sources. So since also professor mentioned that there is no any market demand in Croatia. Nobody will buy the buses because there is no production, and nobody will be produced because there is no any demand. So our approach was in this project was to prepare and to make the clear partnership with city of Zagreb and create the new hydrogen value chain in Croatia. We also see development of the hydrogen market by this European directive, which will where the city buses after 2025 and up to 30 all will need to be used for zero. Will need to use the zero emission fuels. So our plan is, besides to developing the value chain, is to have also three hydrogen filling stations by 2025, and additional 5 by 2030. So it's also mentioned that INA and City of Zagreb, we are today signed a letter of cooperation for the introduction of fuel cells buses in the public transportation. We also were awarded by technical assistance from Fuel Cells Hydrogen Joint Undertaking, and we got this project development assistant until which will be finalized in the mid of 2021. So we estimated for now, but still this is not final figures, that the capex needed for this infrastructure, what we plan to do, first it's around 20 million euros, and we also expect to utilize European funds for development of this new value chain. Now we are in this development phase, and the next 3 years after 2021, we expect that this project will be finalized. I would also like to mention that besides the city of Zagreb, who is our partner in that project, we also closely collaborate with 2 ministries and the faculty of engineering and mechanical engineering in Split, and also in Zagreb. For the next steps, besides to finalize this project, we want to see the other funding options for implementation of this project. We will also continue to actively work with Croatian Hydrogen Association and Hydrogen Clean Alliance. So our resources also are contributing in this hydrogen strategy preparation. We also want to continue cooperation with the scientific community, because we also want to see, besides usage of these new inventions, but also we want to see the potential of the new resources what will be needed for this economy, hydrogen economy, and we want to develop the new business concept for the hydrogen in Croatia, since only transport and our own usage in terms of decarbonization, I think it will not be enough, and we need to expand more. And that would be all from my side. If you have any questions.
Thank you, Damir, for this brief overview of INA's activities.
Yeah.
I'm sure many people in Croatia are wondering what INA is doing regarding hydrogen. So now you show this very well. I don't see. There was a question about what do you envision as the cost of price of future green hydrogen, and I answered this on your behalf that we are still calculating this.
Yeah.
Is that right?
Yeah, this is right.
Okay.
We are still developing that case, and thank you. Yeah.
Okay, thank you. The next presentation, I asked my colleague here at university, Professor Gojmir Radica, to tell us about hydrogen boats and ferries and ships. Gojmir.
Good day. I'm Gojmir Radica, professor at University of Split, and also chief of the heat engine department and member of Croatian Hydrogen Association and leader of the project efficiency improvement, emission reduction and hybridization of the marine power system supported by a Croatian Science Foundation project. So today I will talk about the potential projects in Croatia regarding the hydrogen power boats. As you know, in maritime and transport, we are obliged to obey emission regulations. Nowadays, ship owners are interested in the introduction of zero emission technology for ships, and Croatia has a lot of possibility and advantages to use hydrogen, such as catamarans for coastal traffic and island connections, tugboats, boats in national parks, as well multifunctional barges with the possibility of autonomous navigation, and the hydrogen fuel transport. There is possibility of to produce this electricity directly on boat, and of course other possibilities such as waste management, cruise electricity supply in ports, and the other possibilities. So you know that Croatia has thousands of islands which are ideal for demonstrating hydrogen energy technologies because they have problems with conventional energy supply, but also they have advantages as they are huge possibility to use renewable energy, and the aim for sure will be to develop energy system that will be self-sustaining. Now let's consider some opportunity, such as first opportunity that will be explained here is a small 40-meter ferry for islands that is sailing in South Adriatic coast. Total distance for this ferry is 10 nautic miles. Of course, the propulsion system will be electro-propulsion system, but there will be PEM fuel cells and battery power pack that of course has to be properly designed, and power management control should be properly established for application to optimize the energy consumption according to available energy sources. Second opportunity that we defined is repowering of catamaran that now use two internal combustion engines, 800 kilowatt, and it achieved the velocity 24 nautical miles. But now we are thinking about repowering these catamaran with two electro propulsions. So the battery combined with PEM fuel cells. Of course, there will be problems. Problems could be power supply for charging this battery, as well as hydrogen charging. But now we are trying to resolve all these problems. Of course, there are advantages, and the advantage is that ship owner plans his own solar power plant with electrolyzer. So this project is interesting because the process will be completed with energy production and application, and that will be for sure very attractive for possible EU project or fund. And the third possibility is implementation in 50-meter cruising ships. That is in Croatia, it is growing opportunity because each year 5 to 10 boats were building for these cruising as a cruising ships. These projects are important as they are sailing through our national parks with night encouraging on the island. And here we need green energy, and that for sure is the hydrogen power plant. And for the conclusion, in marine transportation, for sure technology will have to go in the direction that gives priority to battery and hydrogen as a sustainable renewable technology for marine decarbonization. Of course, there should be some incentives such port discounts for zero emission ships, and in execution phase, we have to oblige coastal passenger shipping companies to zero emissions, and then other shipping companies. Of course, you know that the soon Adriatic and Mediterranean will be ECA zone, so IMO3 regulation will be applied. And that is all for the presentation. Thank you for your attention.
Thank you, Goyo, for this presentation. Very brief and very to the point. It will be really exciting to have a hydrogen boats on the Adriatic. We hope some of these projects will realize relatively soon.
That's for sure. That's for sure.
Let's see if I have any question. That's something else. I don't see any question about the goal. So, okay, let's go to the next one. Next one will be on production from waste to green hydrogen. And it will be by a company called SMO. They are one of the first members of our association. And I don't know if the presentation will be given by Julie or by Ivana. Ivana says she has some problems with her voice, so maybe Julie will tell us about it.
Hi, I'm here. I will try to do my best. I'm sorry, as you can hear, I'm a little bit under the weather, but I really didn't want this to stop me from presenting today. And I'm so happy to have this opportunity to present our technology. And thank you very much, Professor Barber, for organizing this webinar. So can you just confirm, please, that you see my presentation?
Yes, we can see it.
Okay. So my name is Ivana Šojukić, and I'm a co-founder of Active Solera, which is a company developing waste to revenue projects in Croatia. And on your screens, you can see an SMO unit, where SMO stands for solar microwave oven, a compact processor fitting into a shipping container. It is a patented autonomous plug-and-play system, whose whole units can be easily multiplied to meet the production site volume needs. SMO transforms all types of carbon-based waste into high added value products worldwide, including remote and isolated zones. So besides being modular and mobile, the unique point of our bioenergy with carbon capture technology is that it is powered directly through solar thermal energy. No fossil sources are used for power ever in any step of the process. Any carbon-based waste is good enough for SMO, even plastics, which brings me to another very unique advantage of this BECCU technology, and this is its negative carbon footprint, even when transforming waste from fossil sources. The versatility of our products allows us to adapt quickly to the conditions and products that a local market needs. Through licenses for joint venture partners, SMO enables them to adopt the philosophy of taking everything from waste and leaving nothing to waste. Natural processes participate to cyclic CO2 exchange, maintaining the balance between the CO2 present in soils, biomass, and the atmosphere. So we all know that the nature does an excellent job. However, human activities, and in particular the overuse of fossil sources, create an imbalance by strongly enhancing CO2 emissions. This is where SMO comes in as a dynamic carbon sink, offering a two-way solution by avoiding new CO2 emissions with the use of bioenergies and by storing the fossil CO2 into long-lived SMO carbon products. So, for example, if SMO were to capture 1 million tons of CO2, it could do so with the 10-unit site over 10 years. So it's just one site with the capacity of 20 megawatts. This would also mean transforming over 84,000 tons of dry waste per year, generating 130 gigawatt hours of clean electricity annually, and more than 7,900 tons of green hydrogen per year. So just example-wise, SMO takes 36 times less land space than, for example, photovoltaics. So this French design technology has already been recognized through international awards, especially since our demonstration site has been built in Morocco on the occasion of the COP22 in 2016. This has allowed us to validate the first technological brick, SMO pyrolysis. Since then, we have validated other crucial steps and are now ready to deploy our first commercial sites. The whole process is composed of 4 main steps, which are all solar powered without conversion to electricity. So the first step is sorting and granulation of the waste input. The second is the pyrolysis. Third one is the gasification. And the last one is hydrogen purification and compression for industrial use. The first 3 steps have already been validated and prototyped and tested. Even though SMO could use a commercially available turbine for hydrogen compression, we are developing a solar turbine together with the system for simultaneous hydrogen purification and compression, which would yield excellent quality outputs and cut the energy needed for compression to half. So with our capex as low as 1.5 million euros per megawatt, our typical 5-unit site with the 10 megawatt capacity represents a capex of 15 million euros, with a 12 million of annual turnover, 4 million net profit over 20 years of plant lifetime. So all of this allows us to propose green hydrogen right now at a price which is competitive to the market prices. Each of our production units may generate a diversity of products, all with the negative carbon footprint and the high added value, which are selected on the opportunities given by the implementation zone. Today, we're putting an accent on the markets aimed by our commercial site in Croatia. So hydrogen and electricity in their classical production modes use fossil sources as raw materials, or in their production cycle. As both are used in energy production and distribution, including their use for transport, they are one of the most impactful solutions to decarbonize our lifestyle, with exponential projections for the next 10 to 30 years. Our ecological impact makes us eligible for emitting carbon credits as a voluntary or mandatory compensations. For all of our products, we are looking to develop long-term offtake contracts with our clients, and we offer them in exchange zero carbon products without the ecological surplus in price, since we hold a position in the lower third range of the market prices. In our Croatian project, together with our partners, we want to offer a solution to turn waste accumulated and forgotten on Croatian islands into green hydrogen and electricity. By developing a boat using hydrogen fuel cells for power, we will be able to transport the waste from the islands without CO2 emissions, additional CO2 emissions. Supporting circular economy principles, we also want to give the opportunity to the islands to manage fluctuations in power needs, especially during high tourism seasons, to avoid power cuts, which sometimes last for several weeks. We strongly believe in making an impact for the future and are proud to propose clean, green, profit machines. Please feel free to contact us via email or phone if you have any questions or wish to simply discuss. We're always happy to connect. Thank you all for your attention, and let's fight together and put good technologies into work for a better future.
Thank you, Ivana, for the very interesting presentations. We often neglect actually waste as an energy source, but waste is not energy source. Waste is a big problem, especially in Croatia and especially on the Adriatic coast, because so far we have no solutions. We are just dumping the waste and then covering with the earth. But this is a great way to create something useful out of it. And of course, I'm very happy that that useful is hydrogen. And thank you. Our next presentation is on the very same topic. So that's apparently very interesting topic also in Croatia, but also in Europe. So the next presentation will be by, I think, Mr. Zlatan Bakalovic from EXOI Green Systems. You have to turn your phone, you have to turn your microphone on. Click on the microphone.
Yeah.
Yes, very good.
Ok. Dobar dan iz sunčane Rijeke. Mala isprika na početku, mi smo ovu prezentaciju baš suprotno napravili, znači sa engleskog baš za ovu priliku preveli na hrvatski, tako da ako nije problem ja ću onda i predstaviti na hrvatskom, but for all English speakers, for interested English speakers, it will be no problem to send it in English language.
I think that's okay, because I think we only have one English-speaking person, which is the next speaker from Toyota. Everybody else will understand you.
Okay.
My apologies to Mr. Kensuke Tsuchiya for this, but
yeah, I'm sorry once again. Okay. Mi smo jedna švicarsko-hrvatska kompanija koja je već ovdje nekih 10-ak godina, ali službeno od 2017. godine. Sa švicarskom tehnologijom koja se zove ultravisokotermalna hidroliza, ultra high temperature hydrolysis. Danas ću vam ja predstaviti u biti nešto malo oko tehnologije, tako da bismo znali u biti što upotrebljavamo, na koji način, kako bismo dobili finalni proizvod koji je u biti glavni dio našeg projekta koji ću vam tamo negdje sredinom prezentacije predstaviti. Hidroliza sam po sebi je proces uplinjavanja organskog materijala u sintetski plin, propuštajući materijal kroz reaktor pod temperaturom 1100 do 1300 stupnjeva Celzijusa u odsustvu kisika, što garantira najčišći plin koji trenutačno jedna usporedna tehnologija može napraviti. Naše rješenje u biti se istraživalo nekakvih 15 do 16 godina i od 2006. je pilot postrojenje bilo na aerodromu u u Minhenu, gdje je u biti 6 godina bilo pod stalnom prismotrom njemačkog TIF-a i gdje je ono u biti položilo ispit i onda 2016. ušlo u industrijsku proizvodnju. Upravo vidimo to postrojenje ovdje. O čemu se zapravo radi? Znači, mi upotrebljavamo organski materijal koji može biti raznovrsnog porijekla. Ovdje vidite, znači da to može biti biokemijski otpad, poljoprivredni ostaci, bolnički ostaci, komunalni otpad. Ono što je trenutačno u Hrvatskoj veliki problem, to je kanalizacijski mulj, industrijski mulj, rafinerijski mulj, otrovni otpad i medicinski otpad. Sve ono u biti što sadrži nekakvu organsku supstancu, na taj način možemo je onda još bolje upliniti. Na kraju procesa izlazi sintetski plin koji ima sastav kojeg vidite upravo i taj plin uvijek ima 40 do 75% vodika u sebi. Ono što nas razlikuje sad od svih ovih tehnologija koje su malo čas bile prezentirane, a vidim da je to bila najviše elektroliza, plin, odnosno vodik u našem sintetskom plinu nastaje kao subprodukt. Znači, on je u biti sastavni dio sintetskog plina koji smo mi proizveli iz organskog materijala. Primjena sintetskog plina je onda vrlo raznovrsna, propuštajući je kroz generator, mi na taj način proizvodimo znači toplinu, električnu energiju i kao što ćemo kasnije vidjeti, možemo proizvoditi i vodik kroz odvajanje posebnom tehnologijom koja je već duže vrijeme prisutna na tržištu. Znači, postoje dva modula, modul od 5 tona na dan i modul od 25 tona na dan, tako da je proizvodnja godišnja sa malim modulom od 5 tona na dan 1600 tona godišnje i sa velikim 8000 tona godišnje, 320 dana u godini. Oni su modularni, znači Lego se mogu spajati i oni su, što je vrlo bitno i što je bilo vrlo bitno za ministarstvo, za odobrenje raznih dozvola koje su nam kasnije trebale, oni su mobilni. Znači, naše postrojenje možete seliti, možete ga kombinirati, tako da u priči koja će malo kasnije biti prezentirana, znači mi bi na lokaciju koju ćemo pričati proizvodili 100 tona godišnje, 100 tona na dan. Ovo je postrojenje, pilot postrojenje koje sam pričao, ovo je industrijsko postrojenje, znači ovo je postrojenje koje je proizvedeno i koje će se u 6. mjesecu instalirati na jednoj lokaciji u Njemačkoj. Ja moram odmah na početku reći da što se tiče projekta, mi smo u jednoj vrlo odmakloj fazi, tako da moram biti vrlo ograničen s informacijama sukladno NDA ugovoru kojeg smo potpisali s investitorom. Biti 99% registriranih otpada trenutačno na svijetu naše postrojenje može tretirati. Ja ću sad jednom brzom crash cursom praktički proći kroz te vrste otpada tako da steknete nekakvu sliku koje su to vrste otpada, znači općeniti otpad, mulj, bolnički otpad koji je trenutačno jako veliki problem u Hrvatskoj, industrijski, komunalni, poljoprivreda i šumarstvo, auto otpad, plastika, industrijski, elektronski otpad, farbe, lakovi, autogume i tako dalje. Znači, što više kalorične moći i što organskije, veća je količina sintetskog plina, a time će biti veća količina električne, toplotne i vodika. I na kraju dolazimo, znači, do samog vodika. Ono što nas u biti na neki način određuje, mi smo negdje između žutog i plavog vodika, tako da ovisi o materijalu kojeg tretiramo, takva će nam biti i boja. Znači, proizvodimo uvijek negdje između 40 i 75% vodika u našem postrojenju. Ovdje je jedan primjer iz nereciklabilne plastike, a to su vam plastike koje nitko više na ovom svijetu neće upotrijebiti, znači vrste plastike koje su pomiješane, čak ih više ne žele ni industrije cementa, ne žele ih također ni u spalionicama a one su vrlo visoke kalorične moći i negdje oko 6 do 7 tisuća kilokalorija, daje sljedeću nekakvu priču. Znači, ako je to ulazna nereciklabilna plastika, 8000 tona godišnje, mi sa jednim postrojenjem možemo proizvesti 920 kg do 1,2 tisuća kilograma dnevno. To znači oko 2700 do 3900 auta na dan možemo natankati, ako je 1 kilogram potrošnja na 100 km, 25 do 35 gradskih autobusa, 25 do 35 kamiona ili 8 do 11 prigradskih vlakova. Znači sa jednim jedinim postrojenjem od 8000 tona na godinu. Ono što je bitno kod naše tehnologije za proizvodnju vodika pomoću UHT-a potrebno je gotovo manje od polovice energije u usporedbi s klasičnom elektrolizom. Za proizvodnju vodika kroz našu tehnologiju nisu potrebna fosilna goriva poput prirodnog plina. I također naše postrojenje, naša tehnologija zahtijeva puno manje procesne energije nego koja je sadržana u otpadu. Sve to na neki način vodik proizveden bez CO2 u procesu čini naš vodik regenerativnim. I na kraju dolazimo do glavne teme, znači naš projekt se zove Green Power Generation Croatia, znači naš projekt nije u nekakvoj početnoj fazi, znači mi smo vrlo konkretno krenuli u taj projekt. Izradili smo predprojektiranje, lokacija je rezervirana, zemljište postoji, lokacija je na neki način za proizvodnju ovog vodika u biti idealna, znači imamo blizinu željezničkog kolosijeka, blizinu luke, infrastruktura već postoji, trafo postoji, znači sve to već postoji i u biti trenutačno se bavimo geomehaničkim istraživanjima sukladno, nažalost, nedavnim događajima tipa potresa, jer želimo na neki način, a to je privatna investicija i investitor se želi na neki način obezbijediti da je lokacija koju smo izabrali, koju smo krenuli, da je ona na neki način koliko toliko sigurna. Na ovoj lokaciji će se inače proizvoditi, znači, osim vodika, električna energija i toplina, za koju smo već našli, znači, krajnjeg korisnika. Poznato je, znači, električnu energiju će preuzimati HEP, za toplinu grad, odnosno komuna u kojoj se nalazimo. I predviđeno je, znači, da ćemo u 3 faze ići. Prva faza bi bila, znači, predprojektiranje koje, kako sam rekao, već gotovo. Druga faza je instaliranje 4 postrojenja. Vi vidite dolje, to su 4 velika, 4 puta 25 tona, to je znači 100 tona na dan. I mi predviđamo da će sa ovim 4 plus 1 malo od 5 tona, proizvodnja biti negdje oko 7 megavata električne energije, topline isto toliko i proizvodit ćemo dnevno 4200 kg vodika dnevno. Znači mi sa jednim postrojenjem u biti možemo komotno ovisnosti od materijala proizvoditi 1000 kg vodika. Sad, šta kaže matematika? Na kraju balade uvijek dolazimo do matematike. Ovdje je jedan layout čitavog tog koncepta. U biti je to, znači, jedna tvornica vodika gdje vidite kako je to sve posloženo. Znači, ne bi se sad puno tu nešto i zadržavao, ali hoću reći samo da nismo na početku, nego da smo dosta podmakli u ovoj ideji. Ja sa ovom prigodom mogu samo zahvaliti, za razliku od svih dosadašnjih žalopojki koje slušamo u medijima i tako dalje, da nas je i ministarstvo, i vlada, i država, i naravno lokalna zajednica maksimalno podržala u ovome, iako smo počinjajući prije 2,5 godine bili, da me se krivo ne shvati, Space Shuttle za onaj stadijum kojeg smo našli u Hrvatskoj. Bilo je mnogo nepoznanica, to sam upravo htio reći. Znači, od planirane proizvodnje vodika koristi da kako imala je lokalna zajednica, s kojom smo upravo pričali na ovu temu, jer lokalna zajednica u biti daje najvažnija odobrenja. Ministarstvo vas u biti samo na taj način poprati i u biti na neki način verificirano što nam je lokalna zajednica već na neki način priznala. Mi želimo biti dio sustava, znači želimo biti dio sustava jer smo jedna multidisciplinarna tehnologija, kačimo energetiku, kačimo znači Ministarstvo zaštite okoliša, dosta je tih zajedničkih točaka i želimo naravno biti dio lokalne zajednice, ne želimo stvarati nikakvu famu oko te tehnologije, pa smo onda u suradnji sa lokalnom zajednicom, odnosno sa gradom i gradonačelnicom razvili isto tako nekakvu PR strategiju gdje od samog početka radimo na informiranju stanovništva i svih onih zainteresiranih, gdje smo na neki način gradu ponudili mogućnost zapošljavanja lokalnog stanovništva, također rješavanje problema zbrinjavanja frakcije komunalnog organskog otpada, otpada mulja sa pročistača, lokalnih građevinskih tvrtki zapošljavanje prilikom izgradnje i na neki način dotičemo se i educiranje jer želimo biti znači i u tom dijelu aktivni, tako da ćemo organizirati školske fakultetske prakse kroz proizvodni proces, dajući toj općini, komuni, zajednici, gradu na neki način važnost i učestvovanje u samom procesu gradnje i izgradnje naše tvornice. Evo, znači naša UHT tehnologija pomaže u rješavanju problema otpada, na čist, decentraliziran i učinkovit način. Ovo decentraliziran je vrlo bitno. Znači, bitno je kad razgovarate sa Ministarstvom zaštite okoliša, prvo šta kad čuju o čemu pričate, o čemu razgovarate, prvo se popnu na zadnje noge i kažu, nemojte nam dirati naš sustav. Znači, mi smo dio sustava, ali taj sustav samo nadopunjujemo. I oni su to razumjeli i imamo njihovu punu podršku. Tako da, evo, nadam se da ćemo evo za nekih par tjedana krenuti u drugu fazu razvoja našeg projekta. Evo, to bi bilo ukratko, nadam se samo da nisam prekoračio vrijeme.
Hvala, ovo je bilo vrlo interesantno. Ima jedno pitanje ovdje, kaže koji je grad u pitanju?
To naravno ne smijem reći jer, kako sam rekao na početku, vezan sam NDA ugovorom i ne smijem još uvijek reći.
Kako? A govorite sa lokalnim stanovništvom, a ne možete nama reći koje je to lokalno stanovništvo? Ne razumijem.
Ne mogu reći jer smo potpisali takav ugovor, tako da ne mogu to reći.
Šta, ugovor da se ne smije znati gdje to radite?
Tako je, ne smijemo još uvijek jer smo dogovorili strategiju sa gradom da ćemo kad zajedničku PR strategiju razvijemo i na onaj kraju i sa PR agencijom da ćemo izaći prema vama. Nema veze s politikom, nego čisto zbog našeg investitora.
Dobro, ne razumijem, ali nije bitno, ne moram ja sve razumjeti. Moje pitanje je samo što ćete raditi s tim vodikom? 4 tone na dan je puno vodika.
To je jako puno vodika. Slažem se s vama. Znači, u toj nekoj prvoj fazi, zašto je, kod nas je jako vrlo bitno da je nama vodik, znači kao što sam rekao na početku, subproizvod. Znači, mi možemo regulirati koliko ćemo proizvoditi, možemo smanjivati taj dotok, a možemo ga povećavati. Sukladno tome kako budemo nalazili krajnje korisnike. Znači, ono što mi sada znamo u ovom business case-u je to da je proizvodnja vodika u našem postrojenju, na ovom industrijskom postrojenju 0,80 do 2,0 eura po kilogramu, uključujući apsolutno sve troškove refinanciranja i komprimiranja proizvedenog vodika na 200 bara. Znači, to je jedna cijena koju nitko trenutačno na tržištu ne može postići.
Dobro, ima još jedno pitanje. Kako rješavate pitanje otpada koji se stvara prilikom proizvodnje vodika iz plastike?
Plastika je u biti vrlo visokokaloričan materijal i u našem postrojenju kroz našu tehnologiju onaj takozvani kolač koji ostane, koji se ne uplini, a to mora biti samo anorgansko. Organsko se 100% uplini. Anorgansko, ako nešto ostane, ono je uvijek do 5% i ono je uvijek inertno, jer je prošlo 1100-1300 stupnjeva.
Da, dobro. Dobro.
A taj inertni materijal možete uvijek, znači, upotrijebiti ili u industriji građevinskoj, znači u beton, cement, asfalt, ili ga možete predati na odlagalište.
Dobro. Hvala, zahvaljujem. Sljedeća prezentacija je trebala biti od Siemensa. Oni su nažalost u zadnji čas sinoć otkazali, ali ja sam zamolio Ankicu Kovač sa Fakulteta strojarstva i brodogradnje u Zagrebu da ona prezentira svoje projekte koje ima na fakultetu. Pa Ankice, molim kratko samo tvoju prezentaciju.
Evo me, stižem, hvala. Samo bi zamolila gospodina Zlatana Bakalovića da klikne gumb Stop Sharing. Hvala. Evo me. Evo ga, samo kratka potvrda, jesam dobro šerala. Valjda jesam. Jel vidite?
Je, vidimo.
Evo ga, ukratko, dakle, nekih... Hi, I will switch on English. Now I will shortly present green hydrogen projects that we are working on in Faculty of Mechanical Engineering and Naval Architecture. This will be just a fast run through the finished and ongoing projects, but more information you can find on hydrogen.hr website. Green hydrogen projects at the University of Zagreb, Faculty of Mechanical Engineering and Naval Architecture, where I am head of Power Engineering Laboratory. Green hydrogen production system. Then we developed first Croatian hydrogen powered bicycle, first Croatian hydrogen refueling station. Then we had the project Croatia Mirai Challenge in cooperation with Toyota Croatia. And two ongoing projects are securing electrical energy in the case of climate extremes and natural disasters, and advanced methods of green hydrogen production and its transportation. Here you can see installed hydrogen production system. Here you can see electrolyzer, and the electrical current we are getting from the solar energy through the photovoltaic modules that are installed on the roof of laboratory. Here you can see first Croatian hydrogen powered bicycle on the road. This is a bicycle powered by 300 watts PEM fuel cell with the hydrogen from 30 bars storage tank. Of course, we need to refuel a hydrogen bicycle, and we installed a hydrogen refueling station. This station currently is okay for refueling a bicycle because it's up to 30 bars. But it is modular, so easily we can switch on higher bars, so we can supply with hydrogen different hydrogen vehicles. This shape of hydrogen refueling station, because of its design, is protected as intellectual property on national and international level, and it is a part of sophisticated equipment installed inside. It is also attractive when you are walking around it, because it has lights and it is a great effect during the night. In this refueling station, hydrogen is also produced using electrolyzer and photovoltaic modules that are installed on the roof of this station. Thanks to this refueling station, Croatia Croatia is marked on a European hydrogen roadmap. So it is noted that it is a refueling station currently for vehicles up to 30 bars. Here we can see our great project that I'm very proud of, called Croatia Mirai Challenge, when we in cooperation with Toyota Croatia organized this road trip from Zagreb to Brussels. And with this project we wanted to promote clean transportation based on hydrogen, and our first refueling station was in Graz, and it was really great and amazing experience. It was a great team. So I hope we will repeat it in the future with the second generation of Toyota Mirai that is currently launched on the road. Current project is securing electrical energy in the case of climate extremes and natural disasters. This was a public presentation of the project in the Hotel Westin last year in September. So this project is funded from European Fund of Regional Development, and within it we will develop the system for mobile and stationary application based on green hydrogen. And its usage in fuel cells. It is also important to highlight that this hydrogen will be stored in a storage tank up to 500 bars, and that means that a part of securing electrical energy, for example, for hospitals and for, I don't know, policy, etc., it can be used for refueling buses, and also at the first stage, and also with upgrading it will be also possible to use it for refueling hydrogen cars that are on 700 bars. And the newest project is funded by Croatian Science Foundation, and it was approved in December last year and officially started in January this year, and we will research advanced methods of green hydrogen production and its transportation. And as the project just started, I don't have photos with the people on it, but I hope soon we will also have this one. The role of hydrogen group of the University of Zagreb, faculty of my faculty, is based on 3 pillars. First one is education, where we are organizing dynamic interactive lectures for students, also workshops for industry representatives, policymakers, and academic staff. We have a workshop called Hydrogen and Fuel Cells, where we also, during the Toyota Croatia Mirai Challenge, organized this workshop, and also as a lecturer there was a Professor Barbir and others. Second one pillar is scientific research, where we are investigating new methods for green hydrogen production. And the third pillar is collaboration. We have a good connection with other academy institutions and industry, and we are working on joint projects related to feasibility studies or some research of components, etc., etc. So why we are talking about this? I really love this slide. I'm proud of it. I invest a lot of my time to design this slide. So pay attention, always keep on your mind that by the 2050 we need to achieve zero emission, and there is no excuses and there is no time. So when we are talking about different energy carriers, energy systems, we always have to have on our mind that by 2050 we need to achieve zero emission. So I think I was fast. So you can always contact me, or you can check our projects and some other activities on this website. Thank you.
Thank you, Ankita, for this presentation. And I don't see any questions. Let me check questions. Okay. Thank you. And we saved the best for last. No offense taken, but I think those of you, there's still 112 participants waiting for this. It's about from Toyota, and it's called Beyond Zero. So I welcome Ken to give us this presentation.
Thank you very much for the opportunity. Fala Lepa, no? I'm very happy to present Toyota strategy today. I'm Ken Sketsuchiya, president of the Toyota Adria, covering the whole Yugoslavia except Macedonia. So let me share with you about my presentation. Do you see now presentation?
Yes, we can see it.
Okay, bravo. So Beyond Zero. So let me explain now about the Toyota strategy. So this is our vision for environment made 6 years ago. Our target is new vehicles zero emission, life cycle zero emission, plant zero emission, minimizing and optimizing water usage and so on. So this is our commitment to the society. We will implement this. However, our target is not just to reduce the emission and achieve the zero emission. Our mission is to create an ever better society, much more than the zero emission, which is beyond zero. While we are focusing now on the autonomous driving, mass application vehicle, robotics, fuel cell vehicles, and boats, and new city with hydrogen energy, our ultimate goal is to be the mass production of people's happiness through our leading electrification technology and mobility innovation. People's happiness, that's why Toyota also focus on the sports. We are the global partner of both Olympic and Paralympic. Sports provide us a positive energy. Sports can inspire the people, and sports can provide a solidarity in our society. In this corona pandemic, we need this power of sports much more than before. I'm sure that you will agree with this. And Toyota's another vision is mobility for all. This means that we want to provide free to move for all humankind, every people with disability, young people, and elderly. So mobility is a very important factor for human's life. So let me move to the environmental data. So this is a result of the CO2 emission per vehicle by the manufacturer in 2019. The CAFE regulation is 95 grams per kilometer by 2020. Toyota is the only company which has below 100, and we will achieve the common target in 2020. We are still waiting for the result into 2020. And this is a chart of a monthly car registration by fuel type in Europe. In July 2020, it is the first time that the electrified vehicle exceeded the volume of diesel, which is very good. In 2019, electric had only 11%, but now 25%, big jump. And this is the same chart, but only for the EVs. As you can see, the biggest increase was hybrid vehicles. Hybrid vehicles are also included in electrified vehicles, and this is our strength. And this is a forecast by the IHS for EV powertrain up to 2030. As you can see, majority of the market for EVs will be hybrid, which is blue. PHEV is light blue, and pure electric and FCV are green. Sorry. This is a chart by manufacturer for the first half of 2020. Lexus has more than 95% electrified, and Toyota is more than 60% electrified. And this is by the country in EU. Croatia is better than middle, which has a 118.3 in the 2019, which is very, very good. However, the challenge for Croatia is that this is the chart for the percentage of fuel type by country in EU as of August in 2020. Croatia is the second lowest country in the 21 countries in EU in terms of percentage of electrified vehicle. Many countries has a more hybrid vehicles or PHEV, which is dark green and green, as well as a pure electric light green. So Toyota strategy. So we have any kind of powertrain listed here. We are ready to provide any kind of powertrain, and our strategy is to provide the best suitable powertrain based on the country's infrastructure and customer demand. We believe pure electric vehicle should be for the short daily distance and the location accessing to plug. For middle distance, hybrid, which is affordable with a more than 50% without running engine, and for extra power PHEV. For long distance and large vehicle fuel cell, this is our view. Regarding our electrified technology, we introduced the first hybrid vehicles in 2000. So we have already 20 years experience. At the time, nobody believed the technology, but we constantly improve our technology, and currently over 60% of our sales is hybrid in Europe. Of course, we achieved more than 60% in Croatia already in 2021 for our hybrid ratio. So Toyota hydrogen strategy. So this is the first fuel cell vehicle in the world, our Mirai, back at the end of the 2014. And we sold more than 10,000 vehicles so far, of which more than 1,000 in Europe. We made this vehicle in order to create the hydrogen society. We launched a second generation of Mirai, and this has a longer distance up to 650 kilometers and only 3 to 5 minutes refueling time. We also use a fuel cell forklift in a factory in Japan. And also we are developing the hydrogen buses and also hydrogen trucks in California. And also working with a partner for the train as well in Japan. We also provide our fuel cell technology to our partners. Here are two examples, Kaitono Bus in Portugal and the Energy Observer. Energy Observer is the first fuel cell boat in the world with our technology. For Kaitono Bus, this is available already. Charging time is below 9 minutes only, but the production, how to say, the lead time is 10 months. So we need to obtain the order if customer need as soon as possible. Many companies have been entering the market one after another, and the need of the hydrogen and the FC technology has been increasing in variety of the applications. So Toyota has developed a product that package a fuel cell system into the compact module and plan to begin selling it in spring of 2021. So these are the areas that we are thinking as partners. And also Toyota revealed a plan to build a prototype of city of the future on the 175-acre site at the base of Mountain Fuji in Japan, called the Urban City. It will be a fully connected ecosystem powered by hydrogen fuel cells. Hydrogen should be made by renewable energy, but more than that, FCEV can be the good energy storage and carrier for the hydrogen produced by the green energy. And then Toyota Group company has a US Energy as an affiliated company focusing on wind power plant in the world. We want to use this power to generate the green hydrogen in Europe. Our sister company, Toyota Tsusho Europe, is trying to offer to bus operators one-stop service for hydrogen, meaning green hydrogen from the windmill, hydrogen station, as well as the FC buses with after sales and finance in Germany. If we succeed this, we might be able to do the same in Croatia. But we need partners. For your information, we also run the hydrogen station in Japan. 2 stations and 6 mobility stations. But the profitability is really challenging. So from our calculation, we need at least 50 FC buses or 800 mirais to be a break even. So as Ankit already explained that we are working very close with the University of the Split and the University of the Zagreb. So this is she already showed, so I skip. So these are the hydrogen by the country. So you know very well, so I can skip, but a lot of countries focus on the hydrogen now. And this is a list of the subsidies in each country. And then currently our focus in the buses, and you can see the grants for the FC buses. So you can see that in the Germany, 80% of the gap between FC bus and diesel bus will be supported by the government. And also 80% of funding of the total investment in infrastructure is covered, and 25% of funding for electrolyzer. So these fundings is necessary to start the hydrogen society. So today's takeaway is Toyota is ready to provide the FC vehicle, Mirai, and FC bus, Kaitano bus, right now. Number 2, Toyota is looking for the partner about the POC, proof of concept for hydrogen business, to start from the start in Croatia. For example, vehicle and the bus, cities, government, universities, companies, hydrogen production side, power company, energy company, and so on. So we are looking for the discussion with all of you if we can have a partnership to start this proof of concept. So, Farah, thank you very much for your opportunity to talk. So, see you soon.
Thank you for your presentation, very interesting, and thank you for being so quick with so many slides. This brings us to the end of our conference, what we scheduled so far. I would like to thank all the speakers. I would like to thank the audience for, there is still 110 of you listening to the end of this conference. Let me check if there are any questions. No, but there is a comment that we should announce a conference at MIPRO later this spring in Opatija. Ankita, can you say a word?
Yes, thank you. We are organizing a regional hydrogen energy conference within MIPRO convention this May in Opatija, Croatia, right? So I'm inviting you all to make your participation. We will organize there round tables, and I also hope we will have more info about the national hydrogen strategy, and I'm expecting to have some guests from the region and from the Europe, also from Hydrogen Europe, and I'm expecting a part of scientific presentations. I'm expecting a lot of useful and constructive discussions on green energy transition based on hydrogen, and that we see solutions and directions how we can make collaboration on a regional and European level. So for sure, I will contact some of you to be my guests. I'm a founder and chair of this conference. This is the first time it is organized with a huge help of MIPRO. So I think we will be able to organize it in a person. And there are also, of course, according to the pandemic, the option to take participation virtually. So maybe we will have everything like this. What is also okay, right? To stay safe, but if the conditions will be good, we will also have in-person some presentations and the roundtable combined with the online. So yeah, be my guest.
Thank you.
Yeah, thank you.
Thank you. With this, I will close this event. I think it was very interesting for me. I hope it was interesting for you that remain to the end to listen to this. We should actually consider having another one maybe by the end of the year. We'll have more information about the ongoing projects and the new projects. So we'll see how it goes. Maybe next year, maybe at the same time, we have another a workshop like this. Thank you all very much, and thank you to the organizers, again, Croatian Academy of Technical Sciences, Croatian Hydrogen Association, and universities, FESB and FSB, and of course, Zdeves, who provided all the technical support. You guys were great. Everything went very smoothly. Thank you very much. Bye, everyone.
Bye.
Gotovo.